you up. You can reshare your slides again and
Thank you for joining us. Thank you for being with us today. And now I want to go one step deeper into some of our most exciting innovations.
Hi, my name is Natalie Mead, and I run the SC team for APJ and Snowflake. And at the beginning of the year, we brought you our Discover series, and that's where we really got into data warehousing and data engineering and building apps on Snowflake. And then in June, we were super excited to bring you Summit, where we talked about all of our new releases like large language models, LLMs, generative AI, Snowpark Container Services. And then after Summit, we were really excited to see you in person at our Data Cloud World Tour. And now we have one more Discover session for you. And if you ever wondered who thinks about our roadmap or who builds our roadmap or who looks at how we're going to release products, well, that gentleman is Christian Kleinerman. And we're very excited that he will be at this next Discover series, and he'll do a Q&A session with everyone where you could ask him questions around what we're doing with LLMs. How is our partnership with NVIDIA going? Where are we looking to move Snowpark Container Services? How do you build a native app within Snowflake? So join us in November. We're super excited to have him here, and we'll see you then.
All right. Good morning. Good afternoon, everyone. I welcome you all to Snowflake Discover. We are on day 2 of our Discover journey. This is our last installment of Discover for the year. But don't worry, we'll be back again. But for those of you who are joining us for the first time, I wholeheartedly welcome you all today. We have some amazing sessions planned ahead of you. We have some customers speaking. We also have some sessions on iceberg tables and LLMs, something that we promised to all of you, well, who attended yesterday. And for those of you who are joining us from yesterday, we welcome you back. Just so you know, we have covered a lot of topics. Yesterday, we went from Snowflake basics, ingesting data inside of Snowflake, Snowpark data engineering, and we talked a little bit more about generative AI. We are going to do a little more deeper dive into LLMs today as well, but we are also going to cover topics like native applications and iceberg tables and LLMs once more. So if you have any questions from yesterday that weren't answered, or if you have any more questions today as well, just use the Zoom Q&A feature and we'll answer all of your questions for you. Remember, there are a few housekeeping items. This is a live event, absolutely free of cost. No robots. I can wave my hands at you and you can wave your hands back at me, and I suppose you are doing that. Invite your friends, invite your colleagues. This is absolutely free, of course. If you feel this is going to benefit them, send out an invite and create a watch party. We highly encourage everyone to use the Zoom Q&A feature to ask questions from our experts. We have an expert panel at hand that will be answering all of your questions in the background. We'll also try to take a few questions live. But just in case, if you get a lot of questions, we'll answer all of them in the chat window and throughout this session. Yesterday, we had Christian Kleinerman, our SVP of product, and Natalie, whom you saw on the video just earlier, talking about all of the Snowday announcement. But just in case if you've missed these announcements, you haven't watched the webinar, this is the QR code. Just whip out your mobile phone, scan this QR code, and it'll take you to the page where we have all of our announcements, and watch the recording. Because if you're in the field of data and you haven't watched all of the announcements that we just made around Snowflake Horizon, Snowflake Cortex, you are missing out on something. So please go watch the Snowday announcements and let us know if you have any questions. Now, with that said, let me invite up on stage Himanshu Shotri. He is the VP of Data Engineering at Grass. And for those of you who don't know what Grass is, Grass provides a SaaS platform that uses predictive AI to scale revenue and drive profitable growth for e-commerce businesses. And Himanshu leads the engineering and data analytics teams at Grass. And he has a very interesting topic with all of you to share. We are going to be talking about elevating multi-tenant data management and how you can unlock scalability and efficiency in data platforms. He has worked extensively on Snowflake. He has a lot of insights to share. He also has some really cool architecture diagrams as well. So if you want to take notes, now is your time. And I now pass it to Himanshu to take you through this amazing journey. Himanshu, good morning. How are you?
Good morning. Good morning, Farhan. Doing good. Hello all. So shall we start?
Let's go.
Yeah, I'll share my screen. I hope you all can see the screen now.
Yes, this is up. Take it away.
So yeah, thank you, Farhan, for the introduction. We'll start off. So let me just spend like 1 minute talking about Grass. So I think Farhan already mentioned that we are using predictive AI to turbocharge the growth for our e-commerce customers. So I'll just skim through the slides. So these are a few of our customers whom we are working with today. So this slide quickly I'll go through. So if you are a brand, like, so you have your own website, you are selling your products on different marketplaces, e-commerce customer, typical e-commerce customer, they would like work with all of these different, companies, different vendors for different purposes. So we have just divided into two parts: demand generation, demand fulfillment, right? I mean, the payment partners, shipping partners, the marketplaces, etc. So what the slide says is one business that you are running with many vendors bringing data silos. Now, what we are trying to do at Grass is like do this, right? I mean, a typical customer working on different platforms, like just consolidate everything onto one single platform, which is called as Grass Turbocharger, right? So this is the idea. So essentially, we integrate various data sources. We provide analytics dashboards. On top of that, we do, we have, ML engines, predictive AI engines, essentially, to provide growth recommendations. So that's like brief about Grass. Let me so we talked about it: connect, analyze, predict. We also do execution, executing the recommendations right from the platform, right? And then we work with tons and tons of data matrices and dimensions, which are, some of them are mentioned here today. So let's jump directly onto the topic today: elevating multi-tenant data management. So this is like, a topic which I have been thinking about like at least couple of years working in Grass, working on a SaaS platform, right, where you have many tenants plugging in. So it's a self-serve SaaS essentially, right? So people can just log in, sign up, and start integrating their data sources. So when they integrate their data sources, what does it mean, right? So let me start off with some of the data models that we have. The data models are pretty complex. I have just like given some high level picture of it. So say you connect ad platforms like Facebook ads, Google ads. This is the typical model that you will work with. You have ad performance data essentially, right? If you work with, things like, Shopify or any marketplaces like Amazon, Shopee, Lazada, etc., this is the typical model that you will work with. So we kind of standardized all these models in our system. And then there are tons of areas, essentially, just not ads, orders. There are other areas too. So the overall complexity of model is quite complex, right? Now, let us understand where we are going to with this, right? So say customer signs up, what happens? So this was the architecture before, maybe like around 6 months back. This is what we were at. So we had our Snowflake account where, say, for example, one customer onboards, we create the models for that customer, right? And depending on what connections they integrate, the data will start flowing into those models. Now, tomorrow, say customer B connects, we again replicate the same model, right? In a different schema, essentially, in Snowflake, right? So these are different schemas. Customer A has its own schema with set of tables. Customer B has its own schema with set of tables. Customer C comes, same. And we keep on doing it for any number of customers we brought into the system. Now, there is an application on top of it, which is Turbocharger we talked about. The user logs in, we get a context of that user, which tenant he is from, like, so the token odds, all that stuff happens. And then the application essentially queries the appropriate schema basis who is the customer that has logged in. So this typical setup essentially is called as object per tenant, right? Like, so every tenant has its own object. The objects are replicated. So this is the summary. You can read out, but yeah, I mean, this is essentially what I talked about. Now, what are the benefits of it? You have data segregated by different customers, but then there are different problems as well. That's what we'll talk about today. So typically what we observed is the scalability became like a real big challenge for us. when we grew from say 30 to 50 customers to now we have 250 plus customers, which are onboarded. So that's where we had to think about, whether this is the right path to go to, like, can we manage those 250 plus customers to maybe when we scale it to 10,000 or 10,000 customers, would it be scalable? Right. So these were the levers essentially. So we kind of set up some ground rules that we need to work on. So there were three pillars to it: scale, adaptability, and user experience. Right. So scale, we always wanted to scale as fast as possible, but keep the costs predictable. Right. I mean, it shouldn't be like linear or exponential cost growth with more and more tenants which are getting added. The second is adaptability, which means that as soon as we get more integration, say tomorrow we start integrating with some new shipping partner, for example, right? I mean, we don't want to like work too much, but then with OPT, you understand, right? We'll have to create the new models whenever the new integration is added by that customer in different schemas. But then, yeah, user experience is one. We don't want to like touch or impact the user experience essentially. So these were the three levers or ground rules which we always wanted to work on, and that kind of forced us to look at what challenges we had. So now, remember that diagram back, which had customer-wise schemas, which means that you will have customer-wise jobs as well, right? I mean, there will be ETLs which are created, but then there were tons of ETLs then became, right? I mean, every customer having their own set of jobs running. So as and when we add more customers, the number of jobs, they kind of incrementally getting higher, right? So that was one of the problems that we had. Then difficult schema management, like one attribute I have to add in one model, essentially we need to replicate that update in all of the schemas. So that schema management started becoming overhead of monitoring as well now, because the number of jobs were increasing. We had to monitor those tons of jobs. So at one point we had like 100,000 plus job runs every day, right? So that was the volume we went into. And then surely, I mean, increased cost, because if you have more and more jobs running, it is consuming more and more compute. That means it's more and more cost. So that's where, we thought like, how should we address the challenge? And then we thought it's time to rethink, re-architect few of these things, how we are doing it. And that's how we went into the area of multi-tenant data platform, essentially, which we'll talk about today. So this is what it summarizes here. OPT approach has its merits, yeah, but then it also leads to various challenges. And that's what we are trying to overcome. Now, what happens with multi-tenant architecture? Now, what we try to do, so there is a lot of effort which has gone in before even we, started thinking or implementing multi-tenant architecture, essentially, because one of the things we always had to do was to standardize our data models, because you cannot have customizations per customer anymore now, right? So let me first walk you through what this multi-tenant architecture means. So same, we have the Snowflake account database. Now we create one schema, which is our multi-tenant schema. This time we call it. We replicate all the models in there, right? Whenever the customer is onboarded, the data flows into the same model essentially. So we won't create schemas per customer, or we won't manage models per customer now. It's single model that is available. The application understands which customer we are querying, and then it kind of goes and queries the same model on the appropriate tenant. Now, surely, I mean, you will start realizing like, yeah, sure, it will have a lot of benefits, because the number of jobs we saw, they drastically reduced essentially, right? It overall simplified the data management within GRAS and improved scalability a lot, because now we never had to think about scaling issues, like more and more customers coming in. It's the same data model we are getting the data into from via the same job essentially, right? And we started realizing that it was a cost benefit solution as well for us. Now, remember again, like, we had to do a lot of work before even starting to implement. As I mentioned, the first one was to standardize the data models across the customers, across The integrations that we had, say, for example, if you have orders data model, that is what it is, right? I mean, whatever entities we design, those entities would be like commonly used across all the customers essentially, right? So there were tweaks which we had to do around our ETL pipelines. We had to figure out like how we will consolidate all the data coming from different APIs, different credentials for different customers into one single place. So we also had to think about, consolidating so we are using Airflow and dbt. So we had to consolidate all our ETL pipelines to bring in data into one single place, which is our data lake, which is behind this, and then processing the data into our data warehouse from that data lake. So we actually, thought about, different technologies. dbt is something that we are using today. But then, yeah, for certain pipelines, we migrated from, say, dbt SQL sort of implementation to Snow pipes. So where the frequency of files was not very clear when they will come. So we just said that, you just keep pushing files into S3 and Snowpipe will keep ingesting that data as and when the data comes, right? So typical use cases were like real-time tracker pipelines that we have, which are the trackers which are installed on different D2C websites of our customer. The events, essentially, we kept ingesting via Snowpipe. And also certain places where the data was coming in the batch, but then it was just like the files were just getting dumped by, the process behind it into a folder, and then Snowpipe kept like, pushing the data into these models. So this sort of simplified our overall, I'll not say architecture, but overall maintenance of entire data management process that we had. It is simplified the data models essentially and the ETL processes. But then, the journey didn't stop there. So even if you start moving your data models into rather multi-tenant data models, you will have to do certain steps, right? Number one, you need to ensure that every model that you have, every table that you have has a unique, not unique, but it has to have one tenant ID to identify each row for which customer it belongs to, right? But then when you do that, when you consolidate all the data from different customer schemas earlier to a single table, the table becomes large. It becomes quite huge, right? We need to then think about, whether the data is partitioned appropriately. So we had to look into certain ways to recluster our data, understand micro partitions, how they work, right? Because they started directly impacting the user experience, which was, if you remember, was the third lever that, we don't want to compromise the user experience. That's where we had to get into then the query performance. The as-is queries which were running earlier, they just were not performing well. So we had to think about query optimization. So even if you say, for example, cluster your tables based on tenant ID, which is what it is, suggested to do. So all your tables should be clustered on tenant ID. The queries which are written on top of those should use, should understand the table is clustered, and then every query has to have a tenant ID as a filter, right? So it has to do the table scans, but it has to be a very limited table scan depending on which micro partitions it has to go and query. So all those query optimization areas we had to look into. So rewrite, certain views, figure out whether certain views can be persisted essentially to get the benefit of clustering, etc. Right. So that was the second area, which is query optimization, and surely monitoring. Now, because few people may think that this becomes like a single point of failure now, right? Because one job is now loading data for all the tenants, and then if that job fails, what happens? Like the data is unavailable for all the merchants, right? So we had to improve the monitoring here. We had to implement certain validation checks before even the data gets into the data warehouse to ensure that whatever data gets in, it's actually correct, appropriate. So some bit of scanning through the files, finding out errors, finding out non-conformant data, and then pushing into the data warehouse, and then put appropriate monitoring system on top of it, right? So these are the things we had to do. So I'll give you one example, right, of query optimization. So what happened was, like, I'll show you one example of the query. So this was the query which we ran on top of the multi-tenant warehouse after we migrated from OPT to MTT. the query was ran as is on the data model, right? And this was the query plan. So earlier the query used to take like a couple of seconds, maybe 1 or 2 seconds. But then after MTT, it started taking 9 seconds. Now, why it took 9 seconds, we had to go deeper into the query plan. So you will see that, it's like a very big query plan. The query was not complicated though, but then it created like a huge query plan with, so I don't know, you can see, but then there were like, these bars you see on the bottom of these, which means that they are problem. So these were the problems essentially. So when we dig deeper into this, we found out that even if we are putting the filters on the tenant ID in our queries, the tables are getting completely scanned. They were still doing full scan, right? Now, then what is the benefit of clustering essentially, right? The problem was that the query is using tenant ID as a filter, but then it is not going into that tenant's micro partition directly and getting the data. So we understood that, we need to rewrite our queries a bit, we restructure the data a bit. So typically you will see these issues when you are using, for example, a view. That view has, CTs inside it. The CTs do not have the tenant ID filters, right? So you need to figure out how to essentially tune it further. We actually did that. Like we did certain persistence. We did like, in certain cases, we figured out that CTs we should not use. We should like just normalize the query in a different way, right? So that the filters are correctly utilized essentially, and then the micro partitions are correctly scanned. And this is what was the result essentially after that, right? So you see the query plan itself became very lean. And then the query execution time then reduced to 1.2 seconds, right? So yeah, I mean, this is something, so I can go deeper, maybe not today, we have limited time today, but I can go deeper into a separate session to explain like how or the learnings essentially from all these exercises we did. So typically, you need to look at a lot of other things after migrating. Now, what did we get as the benefit, right, from moving to multi-tenant data warehouse? So surely we saw in the first month after this implementation was done, we saw a huge dip in our cost, like 25% cost reduction we saw in the first month itself. The journey continues. It is not stopping yet. We are continuously optimizing, like how I showed the query. The lesser the time the query takes, better the costs are, right? So that's what we are working towards right now. This was important. Re-architecture resulted in meeting data delivery agreements. Now, what does it mean is there were agreements within the company to deliver, for example, insights on time, to deliver the data processing. Like we process data every hour in certain cases, right? The batch jobs, they keep running every hour, right? So the benefits that we got is that, because now the data is all consolidated in one big file. Earlier it was, chunks, customer-wise chunks of small files. The processing time reduced drastically, right? So if you have like 300 customers, one job each customer running, taking say 2-3 minutes, it kind of adds up, right? Like it's too much of compute. Now we have one single job which is processing all the data in a couple of minutes, right? So the time to execute has reduced a lot, and thus the time to deliver the data for the further processing steps has reduced as well. So it doesn't just stop there, like the ETL processes, but also think about the processes which are running next, like insights, the recommendations engines which are running. We had similar setup there, like OPT sort of setup where we had insight engine running for each customer separately. Now probably we have to look at consolidating those engines to look at multi-tenant data warehouse tables and then just generate the insights for all customer segments. So this is something that probably is for future, the recommendation engine part. But then yeah, I think insights we could deliver quite easily. Number of jobs, I said, like we kind of have close to 8 to 10,000 runs per day against 100K runs per day. And surely, I mean, the schema objects management has reduced as well. So this is what typical numbers are: reduction in 25% of cost and 10% lesser number of jobs to monitor. So this takes us to the last slide for today, the takeaways. So see, guys, I mean, I am not saying that you all should go and implement multi-tenant warehouse. Like it depends, right? I mean, and that's where I thought this slide is important for you all to take away. So there are, benefits of using one architecture over other. We also started off with object per tenant, thinking that, it provides flexibility, it provides, benefits in terms of separating data by customer, etc., right? And customizations were possible. But then later on, just because the volume of our tenants grew, we thought of changing it to multi-tenant schema. Now, so let us figure out like when we should use object per tenant, right? Now, as I said, if you feel that you will have customizations per tenant, say for example, one tenant may have one table, another may not have one table, or one data model has different set of attributes for one customer and then something else for other customer, you should go for object per tenant because there is no other option then. You can manage RBAC very easily because now the data itself is segregated in every customer schema separately. So management of security RBAC is all easier. If there are specific needs in terms of separating tenant data, for example, you want to track the cost per customer for in your application SaaS setup, then you should still go with this, right? But then there are challenges, as we discussed. It may not scale beyond certain number of tenants. For us, I mean, we could manage it up to probably 80 to 100 customers, but then it became very much challenging beyond that point, right? And then costs. So cost, if it is one of the concerns for you, then surely you need to think about, right? I mean, moving or re-architecting few of these stuff. And last, we talked about managing schema tables is very challenging. So the second part of it is multi-tenant tables. Where you can't do any customization. Or rather, if you do not have any customizations, rather, I should say, then you should probably go with multi-tenant tables. It's a good fit for SaaS-based application with increasing number of tenants. Like, you do not know or cannot predict how many number of tenants you will get because ours was like a self-serve SaaS. So like, we couldn't certain time predict that, how many number of customers would sign up today. So that's where we thought it is like a good fit for us. Scales easily for any number of tenants. I think this is given. But what challenges you may see is that some resources are shared, right? So we will probably use pooled warehouses, like single warehouse doing the job or running the ETLs for all the customers. So you may have certain issues in terms of finding cost per tenant, etc. Right? Additional efforts we had to take to ensure queries are tuned, like how we say it. Tuning was like a challenge to bring down from 9 seconds to 1.5 seconds, ensuring the clustering is appropriately done, etc. Right? And then RBAC, we had to implement tenant ID attribute in every table, then figure out the entitlements, how the entitlements would work, how would app query only that data which it is required to query, right? I mean, so there are concepts in Snowflake you should like surely explore called as secure views. You can use entitlement tables and then use secure views to only expose the data which is needed. So you have to take additional efforts, additional measures to ensure that RBAC is implemented, query performance are tuned as well. Yeah. So yeah, I mean, this is one slide we always show, like, you own your data stack before it owns you, right? So what you should do this is a continuous process to identify unique pain points that you have. You should continuously monitor, how your costs are increasing, how your scale probably is not, I mean, the data is not scaling properly, etc. Be purpose driven and don't forget the end user is important, right? So you should deliver whatever you do, right? Architecture, that, but just to keep in mind that end user is important. So that's where I'll end. So I'll be happy to take any questions now.
Super. Thank you so much, Himanshu, for that wonderful walkthrough. We have a lot of requests from people saying that they want a deep dive session on this topic.
Yeah.
So let's sync up once again and let's see how we can deliver this to everyone. I know 30 minutes wasn't as long of a time as everyone would have expected it to be for a topic like this. But I really want to pick this question up because this is this would also clear some doubt. So there is a question from Bhavesh who asks, as the data is residing in the same data model for all customers, can you charge it back to customer for storage and processing?
Yeah. So that is one of the challenges, and we had to like create a model ourselves to figure out like what is the storage per customer essentially. So we created that, figure out how the processing costs can be divided, etc. So that would always be a challenge when it comes to multi-tenant table. But then I mean you need to create your own model to figure out that approximation of the cost that you are spending to process data for that customer essentially. So that's a very good question, but I think, I mean, I highlighted that as one of the limitations as well. But then you need to, it's not impossible. You need to work on certain models which, fit for your business needs essentially to charge your customers back.
Super. And I know we have covered this during the presentation, but I just want to recap on this once again. So Nick from the audience asks, does a shared database mean that we can use a dedicated database and share it with whomever we want? Or is it more about trade-off of cost efficiency for multi-tenancy?
Yeah, so that's a good question. So dedicated, I mean, there are two concepts in Snowflake, right? One is that, you should still, so this is like shared database in a way that, we are actually sharing the processing of data and then storing all the data into one single database, right? However, Snowflake provides you the capability of, secured shares, etc., right? Which you can, so if, any end customer wants to view their own data, you can surely create a shared view essentially for that customer and share with that customer essentially, right? So you can always segregate that data later as you want, but then this is only for the process optimizations, cost optimizations. We kept the data into one single database, and then we pooled the resources behind it, like the compute, etc. We pooled essentially for multi-tenancy.
Excellent. Thank you so much, Himanshu. I know we are at the top of the hour. I know we have another customer also waiting to present their presentation. But thank you so much once again. Really loved the insight. Really loved the last slide as well. The dashboard being all pretty, and then the data pipelines all over the place. We'll definitely do a deeper dive on this. We have had so many requests in the chat requesting that we do one. So thank you so much for taking out your time. If you're still around, we may have a couple of questions in the Q&A. So feel free to take a stab at them. In the meantime, thank you once again, and thank you everyone who has joined us on this session. We will now move on to our next session, and this session is by one of our customers called Mindtickle, and we have Dhaval, who is the engineering leader and data platform architect at Mindtickle. I see Dhaval has already joined. Hey Dhaval, how's it going?
Hey, I'm good. Thank you for inviting me.
Excellent. So just so you know, everyone, Dhaval is an engineering leader. He specializes in data platforms, data engineering, big data processing. He's spearheading the data platform initiative at Mindtickle. He has more than a decade of experience. He has worked with a lot of startups, and you would definitely know this one. He's worked with Swiggy, and he established a petabyte scale query platform using Snowflake. So he's really good at what he does. And today, what he's going to be doing is he's going to be walking us through, how do you decentralize data, and how did you build a data mesh at Mindtickle using Snowflake. So I'll leave it to Dhaval. And once again, anyone who has questions, use the Zoom Q&A feature in the bottom side of your screen and ask questions. We'll get those questions answered. So Dhaval, all yours.
Yeah, thank you, Farhan. Today we'll be talking about decentralizing data and building a data mesh at Mindtickle, right? Let's jump right in. Today's agenda is I'll speak a bit about the company, what we do, how we do analytics, and what its current challenges are, and then we'll move over to the architecture of the data platform that we have built, and cover some of the data mesh and domain-driven analytics aspects. And then I'll share some of the future roadmaps and some learnings that we have had. And then, of course, I'd be open to any Q&A that you might have. So who are we? We are a sales readiness platform. We essentially help revenue leaders grow their revenue uh, by helping their sales organizations essentially define what is excellence for them, build knowledge based on that excellence, and help sales reps with that knowledge, analyze the performance of those sales reps, both within the platform as well as on the field, and then optimize their behavior to win more deals, right? In terms of data, what this means is essentially we run a lot of programs on the platform, and we need to surface the adoption and engagement metrics of these programs, right? There are a lot of reps essentially take quizzes and assignments on the platform and get their rating scores. We need to showcase that, and then we need to showcase the real world performance of these reps, right? There are conversational intelligence products where we essentially analyze calls, sales calls, and report on their health. There are coaching related products, and we assign appropriate trainings according to those coaching, the outcomes of the coaching. And then, of course, there are business outcomes around how this whole upskilling is actually impacting the winning of deals and growing of accounts, right? A large multi-product portfolio is our greatest strength, right? At the same time, because of that, the challenge is that every product essentially looks at data differently, right? There are learning applications, domains which work on modules and users and how the users get scores on specific modules. There are conversational intelligence products which essentially look at sales calls and analyze those sales calls. We have a product called Asset Hub, where everything is related to sales assets, right? Which asset is good for sharing, which is not, all of those things. So as you can see, all of these, and there are more, these are 3 examples I've picked. All of these domains essentially look at data very differently, right? So the goal we have for this platform is that we want everyone to be able to host and analyze data, right? We need a low-code, no-code framework as much as possible, and a config-driven framework. At the same time, we need to enable product-specific analytics as well as cross-product analytics, right? We, of course, need standardization of interfaces, events, tools, everything. And more importantly, because we have a lot of products, each one of them looks at data and analytics in a different way. We need to enable non-data engineers in those products also to be able to build data products, right? So with that, let's look at what we have today, right? What is the current analytics architecture? Essentially, we have services generating a lot of data. This data is ingested using CDC into a Kafka instance called Platform Kafka. And then we have enrichers which put that data into Analytics Kafka, which is essentially, which centralizes all of the data that comes from different places. And then we have streaming ETLs written on top of this. Essentially, we take the data, we transform that, and then do upserts on Postgres, right? What these are like, the upserts are done onto basic tables, and then of course we have aggregations, pre-aggregations written on top of it, which is done using batch jobs. We use AWS batch for this. And of course, at some point we realized that Postgres doesn't scale beyond a certain scale. So we started writing the data to S3 so that reads become more efficient. And then we have the whole read architecture on top of it, where we have a read replica of Postgres. We have Spark APIs. This is an interesting use of Spark where we actually have Spark applications where we have standalone Spark actually getting and processing all the data and being served via a Flask application. Of course, that has scaling issues, etc. And on top of that, we have other bunch of Node APIs which actually serve the UI. We use technologies like Jasper also in the mix, and we use OData APIs for sharing data with our customers. So as you can see, there's a lot of, and this whole architecture has organically evolved because we were a small company and then we grew big. Essentially, the biggest problems of this are that every single box that you see here is some code that we have written, right? And that needs to be maintained, right? And some of these problems are actually solved problems we'll see in the new architecture. So the first set of issues are technical issues. Too many moving parts, which affect stability, and there's a lot of code to manage. This architecture is actually centralized analytics, which of course creates a lot of bottlenecks. These bottlenecks are both of technical as well as organizational nature. I'll cover the organizational ones in the next slide. Of course, there are a lot of maintenance overheads. So by some estimates, almost half of our developer bandwidth goes into maintenance and operational work in the current architecture. When we do RCA of bugs that get raised, the top bucket that comes in is in code, bugs in code, right? Because of regression, new features, all of that. And of course, one of the biggest things is the choice of technology. We use row stores like Postgres for OLAP. We use ETLs where the world has actually moved to ELT, right? So we transform and then load into Postgres first instead of loading and then transforming. And like I mentioned, we use actually non-clustered systems like standalone Spark for our APIs. Now, those were the technical and architectural issues. There are organizational issues. This I find is more common in the industry. The organizational part of the problem, where essentially there are multiple teams generating data and they just throw data into one place, and there's one analytics team which essentially is responsible for creating all the metrics. Naturally, this becomes an organizational bottleneck. In terms of features, the analytics team always plays catch up. Some feature gets released in the upstream, and then you think about how to do analytics for it. Some little changes that teams keep doing may disrupt the whole pipeline. Like some small flag flip which causes a data surge now suddenly becomes analytics team's problem, right? It even worse. There are situations where it may subtly affect correctness and go unnoticed. Like you are, for example, serving data through one field, and over a period of time you had another field, and then no one communicated that there's another field, and then analytics team doesn't know, and suddenly there's a bug, right? There are these problems that happen. And in all of this, the upstream teams are not responsible for reliability of the data or metrics, right? It is essentially fire and forget for them, especially when the things are like built on top of CDC, right? Because you write it to your database and you forget about it, right? You don't know that the CDC is actually being consumed by analytics and for creation of metrics. At analytics side, the problem is that in a centralized scenario, you typically tend to impose a common data model on whatever you get, right? That does not always work, right? Especially in the cases like I mentioned, where we have various different products and not all of them fit into a common model. So the crux of all of this is that we would ideally like the ownership of the data to be with the teams themselves, as closer to the domain as possible, right? Now, how do we solve these problems? This is the new architecture that we have. We've tried to keep it as simple as possible. So essentially, instead of CDC, we create business events, which are in a very standard format, which get dumped to S3, and they get automatically ingested into Snowflake via Snowpipe, right? And on Snowflake, we have organized the data as source-oriented data products and consumer-oriented data products. These are very common data mesh terminology. Source-oriented data products are the events that we just ingested, and then all the aggregations and analysis that we do on top of that data is powered by the consumer-oriented data products. These are typically facts and dimensions and cubes and all of that. All of this is actually orchestrated via Airflow. We write tags, and the dimension, the facts and dimensions and aggregates are essentially queried by typical clients. Like we use Cube.js. We have found it as a very good tool because now we have like a very predictable data model in the form of facts and dimensions. We are also able to use a lot of BI tools off the shelf, right? And Cube.js is the one we picked because it gives us APIs out of the box. We serve our analytics on our own dashboard, so we need APIs to power our data. And Cube.js essentially just gives us APIs out of the box, right? And it fires queries. It automatically creates and fires queries on Snowflake. So that's our read layer. Yeah. So on top of the architecture that I mentioned, we have built a lot of CI/CD and a testing ecosystem on top of this. So every domain, I'll just go back. So in this architecture, essentially, the only thing that the domains need to look at is the Airflow code and the Cube.js code. Airflow code containing, of course, both of them containing Snowflake SQLs. And that is their core domain logic, right? So they have Airflow repos and they have Cube.js repos, each domain. In addition to this, this whole infra is actually replicated into an integration, staging, and a production track, right? And we do trunk-based development where we merge all the code into a master branch. We do that branch gets automatically deployed after merge, and the tests that are defined are automatically administered, right? And only if it passes a certain testing criteria, it is promoted to the higher environment, right? And for this, we use separate Snowflake accounts for each track, right? Like for integration, staging, and production, there are 3 different accounts. So that helps us segregate the data, segregate test data from customer data and all of that, right? We also have data generation frameworks where we are able to generate mock events for specific test scenarios, right? Generate events and then run the tags and define certain expectations or validations on the output data set, right? So all of this gets automatically triggered after a PR merge on Snowflake. Now, how does all of this relate to domain-driven analysis, right? So the architecture that I just mentioned is used by every domain to publish their business events, like I said, in a standard format. And the events are posted as source-oriented data products. They get processed into consumer-oriented data products. And these data products are actually now shareable across domains also, because everything is in Snowflake. We can just use Snowflake's RBAC model. We can use the grant permissions, etc., to actually share the data across domains. And we can also share the data with our customers using data sharing, right? So here, Snowflake essentially helps us create like a fully automated and self-serve platform where I don't have to worry about node failures, out of memory issues and all of those things, right? It's easy to provision, manage. It's easy to auto scale the infrastructure. The ingestion becomes automated, all of that, right? So now that every domain starts hosting their data products on the platform, essentially this is how it looks, right? This is like a small snapshot of the data mesh that we have built. So imagine that the means user management. The user management domain hosts data related to users and groups. Asset Hub hosts data related to assets and their activities. Call AI, which is our conversational intelligence product, hosts data about meetings and call scores, right? And then we create a Intel domain. This is the product that we are about to release in a couple of weeks, which essentially takes all of this data and creates metrics out of it, right? And creates a score which is specific to that domain. And all of this can now be written as simple Snowflake scripts and just put in the repos without having to worry about the infrastructure and the ecosystem around it, right? This also becomes this framework also helps extend this very easily. Like we have external data like SFDC, the Salesforce data, which has opportunity, activity, quota, all of that data also to get seamlessly plugged into the data mesh. And domains like Seller Intel now can just pull the data in the same way as they pull the internal domains, right? And create metrics. So this is how data mesh actually helps us, evolve. And Snowflake helps us in creation of that common data platform services layer, which is essentially fully automated. So what are we building next, right? So right now we have some bare bones data mesh. We intend to build a complete self-serve, because now as domains come, they get onboarded. All the user management, governance, access control, all of that needs to be self-serve. For which we essentially right now have a operational team which actually creates users and things like that on Snowflake. Although that is easy, but we'd like that to be self-serve going forward. We want to build a lot of new capabilities on top of this. Like there are real-time data processing use cases, AI/ML use cases. We already have a few products that we are going to release that are in pipeline. With respect to this, the testing framework that I mentioned, that is something that we'll be extending more around how do we generate mock data, etc. And of course, data lineage is a big part of observability, where especially in the data mesh, where there are a lot of domains consuming data and the data flows through the system. It's very important to have a complete observability on data mesh or on data lineage. So yeah, so that's all in the future. And finally, I would like to leave this audience with some of the key learnings, especially about who should adopt data mesh, right? I wouldn't say data mesh is a one size fits all. Everyone should start using it, right? Data mesh is mainly for businesses and companies that have many different data domains, a lot of a large proliferation of data types, and the data comes from many sources, right? And secondly, data mesh requires a lot of commitment from product teams and business teams, right? We need to identify that analytics and AI, ML, and data in general is actually a very strategic differentiator for the business, right? And every team in the organization needs to be truly data driven. Every single person, every single team should think in terms of data, right? And of course, with that is like a law of nature. Any change there comes resistance to change, right? That tough decisions have to be made, where you're thinking about how do I go about the progress of the platform versus do I build point solutions to meet certain deadlines, right? And finally, all of this gets culminated in the fact that we need to be able to motivate the whole organization, all the teams, all the domains, to change how they work, right? Because now analytics becomes a very core part of their daily routine, instead of earlier where they were just firing and forgetting about the data and it was someone else's job to create reports, right? So with data mesh, there's a lot of change in the way normal teams, non-data teams actually work, right? So yeah, I think that's about it from me. Open to any questions.
All right. Thank you so much, Dhaval. I think I completely agree and resonate with the fact that, the way organizations are moving right now, the kind of data proliferation that we are seeing from multiple sources, it's not just a technology element that plays a vital role in deciding how you would move forward in your data and analytics journey. It is also a big change management question. As in, we see left, right, and center as much as we'd like to disagree, but there are point solutions being made, and we want everyone to think in a way that sort of brings this collective effort to some fruition, which is where everyone would agree on the fact that, hey, we need to start doing this differently, and that's not it's not a day one or a day two or a day three thing to accomplish. It's a continuous process, and everyone needs to be on board that mission, if I were to put it this way, because if organizations need to differentiate themselves on the fact that they want to differentiate with analytics and AI, then this is the way forward. They need to think of it more also from a process and people standpoint, and not just a platform or a technology standpoint. That is what the 3 Ps of data and analytics, as I'd like to put it. So, Dhaval, once again, thank you. There are a couple of questions here. Well, there were a bunch of questions. Hemant has already answered them, but there's this very interesting question from Rahul who asks, while most of the organization process the transactional and analytical workloads in the data warehouse, there's a unique case where the OLAP was handled initially by the OLTP system. So, is the OLTP still being in use, or are they both in the OLAP stage? Can you give us a little more insight? Yeah.
Well, yes, the OLTP is still being used, and we are in the transition phase. That's the reason why. We typically would like to answer OLAP questions via OLAP kind of systems. So yeah, I mean, I would say still in work in progress.
All right. And Nick from the audience asks, there is an S3 bucket in between Kafka and Snowflake. Is there a particular reason to that it didn't go directly to Snowflake, or was that a conscious decision? And then also,
well, yes,
how long was that? Yeah.
Well, yes, it can certainly technically go directly into Snowflake. We keep that in S3 because we also have other uses of the data, in the sense we have Elasticsearch clusters where the data needs to go. There are audit systems, and essentially this is like an event store where everything that happens in Mindtickle is essentially put, right? So S3 becomes that event store kind of, and then there are use cases around auditing especially, and security, that we continuously keep building based on our customer requirements. So that is the reason why, I mean, also strategically, because it also helps us, tier it out, maybe if we had to save cost, you could just put that into some cold storage, something like that. So yeah, for strategic reasons also.
All right. There's one more question around, and I know we talked about this in the last slide. We talked about, why should anyone adopt data mesh, and what should their strategy look like? We talked about change management, people management, and such. Let's just recap this for the audience, and Abhijit is also asking this question. So let's just recap it once more. What's that purpose? What are those 3 tips that you will give to any audience that is thinking of moving from a traditional architecture and moving towards the likes of data mesh?
Right. So the first and the biggest thing is, if centralization is a big problem, right? We have teams which look at data very differently, right? So I'll give you an example. When we started, we were simply like we had a lot of learning related stuff, right? So we had essentially programs that contained modules and users consuming those modules and getting scores on it, right? So the initial part of analytics was built a lot around modules and maybe modules in a series or things like that, right? Now, as the business expanded, we had conversational intelligence solutions. We had products analyzing sales calls, right? Now there is nothing like modules there, right? So the common model no longer gets extended. So the organic growth of the analytics product now no longer is extensible, right? Now it needs to change very fundamentally, where you're able to enable all these teams do their analysis. And tomorrow we have like 5-6 different products. Tomorrow you have like 10-20. You don't want to be in a situation where now the whole this one central analytics team essentially is trying to understand every single data point that every single team in the company produces, right? So that is the crux. That was the trigger point at which we started thinking about data mesh.
Excellent. I completely agree with you. I think we think of analytics teams as the know-it-all of data and analytics, but
yes,
I think that can in a lot of cases it can do more harm than good, and we need to think of this as a collective exercise where we are bringing in both responsibility and federation inside the data and analytics organization and the organization overall, because the domain teams are the ones that will have the best context of the data. I mean,
yes,
I could give the analytics team as much information as possible, but the context, the domain expertise, the subject matter knowledge all stays with those teams. So it is a collaborative effort. So organizations that are looking to move towards data mesh, they need to start rethinking how to solve this from a fundamental standpoint. How can we solve this foundationally? So that's an incredible insight, Dhaval. I know we are at the top of the hour, but I really want to thank you. We have a few questions open in the chat. So if you're going to be there on the backstage, take a stab at these questions in the chat itself. We may just want to do a deeper dive of this particular topic sometime in the future because the audience here in India and in the region loves getting these insights and getting to know how all of this works. So thank you so much for taking out time and walking us through this incredible session. For those of you who have stayed with us up until this point, I thank you, and I would like to remind you that we will take a very short break. Just go and grab yourselves a cup of coffee or beverage or water, anything at all. We'll be back in a minute. We are back with Iceberg Tables and Snowpark Container Services. If you want to know how you can productize your machine learning models natively inside of Snowflake, this is your session. We'll have Ritabrata Saha joining us in a few seconds from now. So just take a minute, grab yourselves a cup of coffee, and we'll be back. Thank you. All right. Good morning. Good afternoon, everyone. I welcome you all to Snowday Discover. If you were there on the previous sessions, we just had Dhaval and Himanshu from Mindtickle and Grass, respectively. They were talking about data mesh. They were also talking about multi-tenant architecture. So if you have missed that session, let us know. We'll do a deeper dive on those sessions once again. But for now, we are going to move on to some of the interesting announcements that came out during Snowday. And for those of you who don't know what Snowday is where we make our featured announcements. And for those of you who were already there on this bridge yesterday on Discover and today, you already know the format. But those of you who are joining us absolutely brand new, I welcome you all to Discover. My name is Farhan Chaudhary. I am the evangelist for Snowflake in India. And I want to remind everyone that while we are talking about Snowday and all of the announcements that came out, this is still a work in progress. Once we release these features out on the platform, once they become generally available, there might be some change. So since we are talking roadmap items, we just want to remind everyone that this is not a commitment per se, that what you're seeing here today is exactly going to be there when the product becomes generally available. We might have some additional features, and we'll again walk you through all of those additional features. But for now, whatever we have, we are showcasing. And I just want to remind everyone of that fact. Now, that being said, we have been doing Discover since yesterday. We talked about data engineering. We went through data ingestion and the basics of Snowflake. We also talked about generative AI. And today, what we are going to be doing is we'll walk you through Snowpark Container Services, Iceberg tables, LLMs once more, just to remind us, and then also talk about the art of the possible inside of Snowflake. So just stay tuned with us. We have a few more topics in mind and what we'll want to walk you through. Some housekeeping items for those who are joining us for the first time. This is a live event. It's absolutely free of cost. Invite your friends and colleagues if you feel they are going to benefit from this session. If you have questions, use the Zoom Q&A feature. You'll see that either on the top of your screen or on the bottom of your screen. Just ask questions from our experts. We have an expert panel at hand. They'll answer all of your questions for you. And if you've missed the Snowday announcements, if you're in the field of data and you haven't watched the Snowday announcements, the video, the recap, the recording, whatever, if you haven't watched it, you're missing out on something. So just scan this QR code. We'll also push this link on the chat so that you have it handy with you. But I'll just leave it on for another couple of seconds. Just grab this QR code and watch the Snowday announcements. Now, with that said, let me bring up on stage a dear friend and colleague, Ritab, who is going to be walking us through the preview into Iceberg tables and Snowpark Container Services. So Ritab is here, and you are in great hands, audience. Take it away, Ritab.
Thank you very much. So very good morning and afternoon or evening, wherever you are based on the world. Warm welcome to the Discover session. So the agenda for the next 1.5 hours is about Iceberg tables and Snowpark Container Services, as Farhan mentioned. And Farhan, thank you for the great introduction. And with that, we get started. I'm going to share my screen. I hope my screen is visible now.
Yes, it is. Take it away.
Okay, fair enough. So before we dive in, just a bit of background. Let's look at what is Iceberg. So before we get in to the details of how Snowflake leverages Iceberg, let's understand what is Iceberg, right? So Iceberg is an open table format, which is used for analytic data sets, right? So people who have been playing around with huge data sets in the analytics world are quite familiar with this particular open format, right? And why is it of importance? What is that particular use case that makes Iceberg the go-to choice for most of the practitioners today, or most of the data practitioners today? It's because Iceberg provides an opportunity for us to interact with an open table format using multiple platforms. We can use multiple technologies to talk to this particular table format. It's not a proprietary data format, and that's the beauty of this particular data format, right? What is the major benefit? Iceberg gives us pretty high performance with consistency, and it gives us an ACID compliance data structure. Very unique features, as I was talking about. It is agnostic of the processing engine. So you can have an Iceberg table format with which you can interact with Spark, you can interact with Snowflake. At the same time, you can read and write with both these technologies into this particular data format, right? Moving on. So why did we choose Iceberg? Now, in the open source data format world, there are multiple other data formats as well, or multiple data formats available as well. Now, why did Snowflake choose to embrace Iceberg? The first reason is the project velocity. So what do I mean by the project velocity? So if you look at the contributors to the Iceberg channel, there are multiple contributors to this particular forum, and this is widely adopted in comparison to the other competitors in the open data format world. This is very, very competitive, right? It got a vibrant ecosystem. There are many commercial and open source engine integrations which are available on top of Iceberg. Like if you talk about Informatica, if you talk about Metallion, if you talk about Fivetrans of the world, they all support Icebergs today. Interoperability. What does interoperability mean? It's primarily means that we are not locked into a vendor. So when we were talking with multiple customers, we heard our customers saying that, hey, the data format that Snowflake leverages, they're great for the Snowflake performance, but then we are locked into Snowflake with that particular data format. So we heard our customers and we reacted to that, and the response was embracing Iceberg. Right. So as I started talking to our customers, let's put a little focus on the customer challenges, the challenges that the customers were facing. The first one is control. So customers started asking us that while Snowflake storage is great, but not always do I need a Snowflake storage. If I have to get the data out of Snowflake, there's no way other than the Snowflake compute engine that I can get the data out of it. Now, there are situations where the customer wanted that flexibility, and that is where we reacted to that particular question from the customer. The second is cost. Now, while Snowflake cost is really cheap, but then there are storage, storage possibilities which are even lower than the cost that we provide. And the second thing is, most of the customers are not happy with maintaining two copies of your data, because if your data format is not open, if it is not interoperable, then you'll end up creating two copies of the same data. Now, that's definitely not a go-to choice from a governance perspective, and hence we as Snowflake, we had to react to that. The third one is ecosystem. Now, with the analytic world ever evolving, we have every customer is using multiple technologies to transform their data to drive actionable insights from their data. Now, while the customer tries to do that, they want a data format which can be used using multiple tools, right? Now, with these customer challenges, we heard our customers and we reacted to that, and we brought Iceberg to the table. Now, what are the benefits that we are offering today? Right. The first one is, the first one is the benefits of Iceberg. It's an open standard. As we all know, Iceberg is an open standard. And with Iceberg tables coming into the picture, data can be stored outside of Snowflake. We can process the data we can read and write that to that particular storage, not only with Snowflake, but with other compute engines as well. So we will see that in action towards the end of the session. Cost effective. Because it is interoperable format, customers do not need to maintain multiple copies of the same data. They can very well work with a single copy of the data. Engine agnostic, again, because it is an open source format, the same copy of the data can be actioned with Snowflake compute, and at the same time, maybe some other computes like Spark. For those of you who have been following the Snowflake announcements, Iceberg have been in discussion for quite some time. Back in 2022, we announced Iceberg external table support, but now we are deprecating that particular Iceberg external table support, and we are bringing in something native Iceberg tables. We will see what are the benefits that native Iceberg tables brings to you as a customer. But then, yeah, so from now onwards, from 2023 onwards, we are bringing native Iceberg tables to the table, and the Iceberg external table format, which we spoke about in 2022, has been deprecated. Right. So Iceberg has been in preview. So as we speak, it is in preview, and it has been in preview for quite a few months. Customers were very, very excited about this particular preview feature. Multiple customers adopted, and on the screen, you can see some of the results that came out from the early adopters. So we had table sizes ranges from 0 to 900 terabytes. On an average, a customer who adopted Iceberg tables, which is in private preview today, he created almost near to 125 Iceberg tables, and the average number of jobs that were triggered on these Iceberg table format, the data which is stored in the Iceberg data format, were greater than 1,000 for this particular period. So there have been a fantastic response from our customers during this private preview feature, and we are excited that this particular feature will be available, will be made public preview very, very soon, maybe in another 2 to 3 months. So let's look at Iceberg tables to a deeper dive. So Iceberg tables today, as you look at it, it converges the native Iceberg tables and the external tables, which we announced in the last year. Now, what does it offer to you as a customer? It brings in a single table object. So you have only one object, which gives you the benefits of the native and external tables both together. So on the right-hand side of the screen, you see that the 3 benefits which I have been talking about in the previous slides are also highlighted here. That data is stored in Apache Iceberg open source standards. There's a huge cost savings because it's one data format, one table, one copy of the data that you maintain. You don't have to manage multiple copies of the data, and hence, not only do you save on the storage cost, but on your governance cost as well. And you can use multiple computes at the same time to engage with this particular data set. Right. So this brings us to a point wherein we should discuss about workloads. So what are the different workloads that generally addresses this particular feature? The first one is your data lake, because most of the customers who are building data lake, they came back to us saying that, hey, I have a data lake, but then I do not want to store all the data in the data lake within Snowflake, because I use that particular data lake with other computes as well. So that makes Iceberg the go-to choice for these kind of use cases, and data warehouses as well. So the same applies to data warehouses where the data needs to be there in one open standard, accessible to multiple technologies. Who does it impact? It impacts all the industries. This is definitely not industry specific. This particular feature is applicable to all the industries today. And from a personal perspective, starting from your developers, data scientists, everybody gets to access this particular feature and start transforming data, start generating insights from that particular data, and keeping a single copy of that particular data on their data lake. Why is it important? Because Snowflake, it's like Snowflake as a platform, while it gives you a fantastic compute to operate on the Snowflake managed compute, but then there are multiple scenarios on data lake environment wherein you as a customer or you as a developer definitely want to transform the data which is there on that data lake, not just with Snowflake, but with some other technologies as well, right? Right. So we are deprecating, as I was talking about, we have deprecated external iceberg cables and we have deprecated native iceberg cables. And all you have is today iceberg cables. And this iceberg cable is a combination of iceberg external tables and native iceberg cables. So today, in Snowflake, iceberg is a single table object. Right. Now, we've been talking about, the benefits of iceberg. Now, in order to create an iceberg table, there are few steps, a few fundamental steps. And on the screen, you see those fundamental steps. Number one is you will have to create an external volume. So external volume is again a first party object in Snowflake. So what does an external volume mean? External volume is and it's a connectivity to your cloud storage. So let's say you have an S3 bucket wherein you are having all your data files for your data lake. So you will have to create an external volume pointing the location of the volume to that particular S3 bucket. It can be an S3 bucket, it can be an Azure blob as well. So the first task, while you create an iceberg cable or on the journey to your iceberg cable in that particular steps, the first task is to create an external volume. The second step is catalog integration. So we will see what does catalog integration mean, because iceberg cable today supports two different type of catalogs. One is a Snowflake managed catalog, and which is an externally managed catalog. So there are two different catalogs that Snowflake supports today. We will see that in action. We will see what they mean and how different they are, what are the different pros and cons, and when do we use what in the upcoming slides. But then you will have to build a catalog integration. If you're using Snowflake, if you're using Snowflake as a catalog, you don't have to build it. It is built automatically. But then if you have to use a catalog which is external to Snowflake, you will have to create that particular integration. Now, once your external volume and your catalog are created, it's time for you to create the catalog, the iceberg table. Right. So we were talking about a catalog, right? So Snowflake, Snowflake iceberg tables today helps you or provides you two ways to create your catalog. Number one is your Snowflake catalog, and number two is your externally hosted catalog. So we'll take a look at what Snowflake catalog means to you as a developer and you as a customer. Number one is you get to use Snowflake read and write. So let me start my pointer. So on my mouse over, you get to do Snowflake read and write. So if you're using Snowflake catalog, you can use Snowflake to read and write onto that iceberg table. Iceberg interoperability is definitely something which Snowflake catalog offers. Full platform support. Now, when I say full platform support, I mean features like clustering, features like micropartitions. So very similar features to these are automatically enabled on your iceberg cables if you are using Snowflake catalog. And because you are using native Snowflake features, it gives you performance which is very, very comparable to Snowflake managed table. So if you are using Snowflake catalog on your iceberg cables, that means you are going to, it's like, you're going to get a feel of Snowflake managed table. The beauty of Snowflake managed tables, whoever have been using the Snowflake managed table, the rapid performance, the clustering, and all the latest and greatest features of the world, whatever can be enabled on a Snowflake cable can also be enabled on iceberg cable, which is having a Snowflake catalog. Now, how does this work? So now that I have spoken about what is the Snowflake catalog, let's see how does it work. So on the left-hand side, you have the data ingestion. So while data is getting ingested on your iceberg cable that you have created, what happens is the external volume. So from the iceberg cable, the data moves onto your external volumes. And on the external volume, data is stored as a Parquet file. In the same time, when data is pushed onto your external volumes, the catalog is updated. The Snowflake catalog is updated, and this leads to the update of the metadata as well. Because this metadata is very important, because this metadata keeps track of what is coming in at what rate. It does a lot of activity in the background, which drives intelligent querying on the Snowflake warehouse. Now, once your external volumes and your catalogs are updated, at the same time, you can use Spark to read and write from this particular data. Now, as we speak, this particular feature is still on private preview, so we can use Spark to read the data from Iceberg tables today. But then, before the developer team is constantly working towards it, before we go public, before we launch our public preview, we are going to we're going to allow Spark to write data to the customer managed storage as well. Few syntaxes. So we were talking about creating an external volume. So this is how you create an external volume. You see the name of the volume, the storage provider, the storage AWS ARN, the role ARN, and the storage base URL. This is primarily the storage base URL is nothing but your bucket location and the maybe some folders within the bucket location, right? Allow write by default it is true, but then if you do not want to use it, you can set it to false. Once the storage integrates, the external volume is created, you create a empty Iceberg table. And there you mention the catalog as Snowflake. Right. So how does Snowflake on top of the Iceberg layer, wherein we are using SDK to communicate with the Iceberg storage. We are also building a REST API with which you should be able to communicate with the Snowflake Iceberg table. And as we speak, the team is constantly working towards Spark as an engine or any other compute engine which can read and write at the same time to the customer managed storage. This is something as work in progress, but the demo that we will see in action towards the end of the presentation, where I'm going to show you how Spark can be leveraged to read data from the customer managed storages. Right. Now, the next variation of the Snowflake, the Iceberg table is the external catalog. Now, we have seen what benefits the Snowflake catalog offers us. Now, not every customer is always looking forward to, create a catalog on Snowflake. Now, in case the customer is not willing to create a catalog on Snowflake, what options do they have? Today, they can create a catalog on Amazon AWS Glue. So there are a few onboarding options. Number one, the Iceberg catalog. Number two is your Iceberg metadata. So if you are not using Glue, you can bring in the Iceberg metadata as it is today. And at the same time, you can bring in Parquet files. So this is something, again, a work in progress. Once the public preview is announced, I'm sure this is going to be on the truck. You should be able to create public, Iceberg tables straight on top of your Parquet files. What does it offer? Flexible sources. As you can see, you can read data from multiple sources. Efficient onboarding, simplified operations. Now, yes, they are simplified operations, but they are not as good as the Snowflake catalog tables. So we will see a comparison between the Iceberg tables, wherein you create a catalog on external catalog or on Snowflake. We will see that differences. But then external catalog does come with some challenges. But then because it is the metadata is not stored within Snowflake, and Snowflake intelligent engine is not aware of all the metadata that is stored in an external catalog unless the query is hit, right? So that is the reason the external catalog doesn't give you all the features of a Snowflake managed table to play around with. Right. So External catalog, how do they work? It works very similar to your Snowflake catalog. The only difference is your catalog integration. So if you remember in the slide when we were talking about Snowflake catalog, we did not have the catalog integration in place because it was evident that Snowflake, we are using Snowflake as a catalog and we don't have to create a catalog integration because it's all within Snowflake. But here we are creating, we are using Amazon, AWS Glue as a catalog, and hence the catalog integration has to be created. Other than that, everything remains the same. Few syntaxes while you create Iceberg table based on an external catalog. So very similar to the Snowflake catalog, you create an external volume. Then you will have to create a catalog integration. Now, what do you mean by a catalog? I mean, what are the two different type of catalog integration? You can use an object store or you can use AWS Glue. If you are using an object store, you will have to create a table in this particular format. And if you're using Glue, you have to create a table in this particular format. So these are bare minimum syntaxes. I'm sure you will be assisted with a very rich documentation once this hits public preview. Right. So we've been talking about how Iceberg tables helps us. But then let's look at some of the performance matrices, because Iceberg has been in private preview for some time. We have been interacting with multiple customers, and we definitely have some numbers to explain the cause. So we started with external Iceberg tables, but then the moment Iceberg tables with external catalog was launched, we saw 2x performance improvement, right? And there was further performance improvement the moment we moved from an external catalog to a Snowflake catalog. The primary reason is the moment we create a Snowflake catalog, the Snowflake micropartitions kicks in, and the Snowflake intelligent layer can come into action. You can create clustering on the data sets, and hence the performance further improves while you move from external catalog to a Snowflake catalog. And this particular performance is very much in comparison to your Snowflake format table, which I mean the managed table. So these two are very much in sync, and hence, given a choice, we recommend our customers to use Iceberg tables in the Snowflake catalog. Okay, this is what I was talking about, just a comparison between the Snowflake Iceberg tables having an external catalog and having an internal Snowflake catalog. Now, I'm not going to go through all the pointers on the screen. You can read it, but then some of the most important pointers which I would like to talk about is the access. Now, if you look at the third one, with external catalog, we allow external write, but then Snowflake can only read the data from that particular Iceberg table. But if you're using Snowflake catalog, Snowflake and external computes can read and write simultaneously on that particular data set. We have spoken about interoperability. Let's talk about the performance a little. Managed table optimizations. Yes, you get managed table optimizations, but certain features like clustering may not be available when you are using external catalog. But then if you're using internal catalog, all the performance features or the optimization techniques that you can enable on a managed Snowflake table can also be enabled on Snowflake catalog Iceberg table. The last one is the support for the structured data type. Both external catalog and internal and Snowflake catalog, they support nested, map, list, and array. The question that we often get is, why doesn't it support a variant data type? Now, the reason is it doesn't support a variant data type because variant is not an open format. Variant is something which is very internal to Snowflake. Now, if you want to use the variant data type, you will have to use the Snowflake managed table. Iceberg is not going to help you in storing data as a variant, because that's not something which is an open format, open data type. Right. So talking about availability, it is available, across all the Snowflake supported platforms and the Snowflake supported regions today. Right. Let's go over to the demo. Right. So what do we have on the truck? Okay. So what I've done is I've created an external volume. So if you remember, so what are we going to talk about in this particular demo? We're going to talk about Iceberg tables with Snowflake format, with Snowflake as a catalog format, right? So the first thing, if you remember, we have to create an external volume. So I've already created an external volume out here, which is pointing to an S3 bucket. Now, because I'm using Snowflake as a catalog, I will not have to create a catalog integration. If you see over here, the table that I created, this table is already created and it is using Snowflake as a catalog, right? Now, if I run this table information command, it tells me where the metadata is located and a status, right? If I do show icebergs, it shows me that I have two iceberg tables. We will see them, what I have stored over there. So you can see they're on the external volume, the catalog. Both of them are using Snowflake as a catalog, and both of them are managed iceberg tables. Right. So what is the data size? So I don't have any data on this particular table today, right now. And I'm going to insert some data from the TPCH customer data. So let's go ahead and insert a few records. I think it's going to insert 150,000 records. It is inserted from the TPCH customer table to the Iceberg table. If I go to the Iceberg table, you can see that there are 150,000 records that is inserted into the Iceberg table. Now, if I go to my AWS bucket, you can see on the customer, it is loading and I have the Parquet files created because it has loaded the data on the external volume as Parquet files. Now, it's time for us to move on to Spark. Let's see if I can access this particular table using Spark. So what I've done is, before coming to the session, I have already installed Spark on my local machine. This is what you see, Spark on my local machine. I have already, instantiated all the environmental variables so that this particular Spark instance can connect to my AWS instance and read the data from the S3 bucket, right? So if I go to this particular command, if I run, I see 150,000 records. Now, as I during the presentation, I spoke about that right now as we speak. In the current state of the private preview, you can use Spark or any other compute to read data from the external volume, the customer hosted external volume. But then before we go public, I'm sure we are going to have capabilities wherein I can update this particular data set as well. Right. This is all I wanted to show you guys today. Open to any questions. Sarita, how are we doing on the question answer front? Do we have any questions that you want me to talk about, or we are good?
Just taking a look at some of these questions.
I'm just reading here. I can see how about data security being stored externally. How enterprises will rely on the storage, be sensitive and PII on Iceberg. See, that's a conscious call the enterprise will have to take. It is imperative that if you as an enterprise is taking the decision to host your data outside of the Snowflake data governance boundaries, you do have separate checks and balances wherein you know how to protect the data which is stored outside of Snowflake. So if you are not very sure that is your data really secured when it is stored on S3, do you have all the checks and balances enabled on S3, then we would recommend bringing the data to Snowflake managed tables and we will do the job for you.
When is it available on Azure? The demos are focused on AWS. Yes, the demos are focused on AWS, but then the private preview is already available on Azure. So I'm not sure if you are, if you are a customer, then please reach out to the Snowflake sales executive. They will get it enabled on Azure for you, and you can start playing around it. Is it faster than Snowflake Managed Table? So if you remember, I was talking about I was giving a picture of how performance improved as we move from external Iceberg tables to Iceberg tables, which is having an external catalog, then Iceberg tables on Snowflake catalog, and Iceberg tables on Snowflake catalog are having a very similar kind of a performance compared to in comparison to your managed tables. Cost-wise, any savings if I store data in Iceberg tables? Okay, if you store data in an Iceberg table and your data volume is external to Snowflake, Snowflake has no control on the cost. Now it is up to you as a customer to choose the storage provider as per your contract, wherein you can get the benefits of cheaper cost. If you're not sure that whether your cost of the storage that you are subscribing to is going to be cheaper, then we request you come and store the data in Snowflake managed tables. Because when the data is stored outside of Snowflake, we really cannot control or dictate how the pricing is going to be, right? How one can recognize Iceberg or normal Snowflake table. If you do a described table, you will definitely be able to understand whether it's a managed table or whether it's an Iceberg table. Can we both query Iceberg tables and Snowflake native query in a single query? Yes, you can. You can definitely join a Snowflake query and a native a query which uses Iceberg tables and Snowflake managed table in a single query, join them together and play around with the data. Okay. Any more questions? Can we compare data size in storage? There's no limitation. That's what we can tell you. So if you remember on the third or the fourth slide, I showed you that there was a customer who had stored close to 900 terabytes of data on an Iceberg table. So I think that there are no limitations as such that we have come across with. Does clustering need Iceberg table? The question is, I think, the other way around. Can clustering be enabled on an Iceberg table? Yes, clustering can be enabled on an Iceberg table, which is having Snowflake as a catalog. Why only Iceberg table support has been added and not Hoodie? Okay, it's a very interesting question. So Hoodie definitely was there on the list when we were debating on which open table format to choose. And the reason we went with Iceberg because of the great community which is supported, which supports Iceberg, and the support from all the enterprises, the adoption of Iceberg in the open format data ecosystem is much higher than Hoodie, and that was the only reason we embraced Iceberg. Any more questions? Anything that's coming up? If an Iceberg, I'm just scrolling up, if an Iceberg cable is created in Snowflake Iceberg cable, could you use AWS group caller to crawl directly on AWS and get the accurate file definitions? Yes, you can do that. How can data security? Okay, I think we have almost answered all the questions. How can we compare data size? No. Yeah, fair enough. For the cost of storage, usually the cost increases with the size. Example, Parquet cheaper than CSV. On those lines, can we compare Iceberg versus Snowflake versus Iceberg for the same data? Well, if you are choosing Snowflake, then definitely Snowflake is going to use grade 1 compression mechanisms, and that makes the storage much cheaper, right? So if you're using Iceberg, then you will have to be happy with the compression that Parquet allows by default, and on top of that, I don't think you can compress it further. But then if you are using Snowflake, yes, Snowflake will allow another level of compression on top of what Iceberg or on top of what Parquet offers. When we will have Unistore and cost in which session, that is something I don't think we are talking about Unistore in the in the sessions that are planned in this particular week. Maybe in the upcoming one we will talk about Unistore as well. Farhan, maybe you can correct if I'm wrong here when we will have a Unistore session. How many Iceberg tables can we create in a single account? Many. There are no limitations. Fair enough. If we are done, maybe we can move on to the next session, Farhan.
Yep, let's do. Yeah.
Okay.
Yeah.
Let me. I don't see any more questions coming up on the channel. Christmas 2, that's fine. I'm going to close this. I'm going to close this as well. Let me bring in the pick for container services. Right. Okay. So container services is another feature which is in private preview. Very hot topic. There are tons of customers who were waiting for us to launch this particular feature. And the moment this particular feature has been put on the table, we had many who opted for an early adoption. So with that, what are we going to talk about today? We are going to talk about container services. We are going to talk about Snowflake platform for LLMs, because we promised we will talk about LLMs, but then before we get into LLMs, it is very, very important that we talk about container services, because that is what is going to make LLMs operational within the Snowflake environment, right? We will show a quick demo that I have put together to show our container services in action. And finally, we will look at some of the use cases, right? Background. So why did we bring container services to the table? What were the different problem statements that our customers were facing that made us think about something like a container service to be hosted within the Snowflake ecosystem? Number one is adoption capabilities. Now, many customers are bringing in containers. The business logic is already embedded in a container. Now, do they really want to go through a migration journey wherein they are moving the code out of the container and refactoring them in a programming language which Snowflake supports? Not really. So for those customers who are already having a business logic within containers, container services is an ideal way to bring business logic within Snowflake. If you have a front end, so let's say you have built a data application which is having a front end. Now, this particular front end, as you all know, Snowflake supports Streamlit today. But what if you would have used something else other than a Streamlit application to build your front end? How can you bring it to Snowflake? Snowflake Container Services is your go-to choice. Custom runtimes. So Snowpark allows you to code in JavaScript, SQL, Java, Scala, and Python today. What if you have a custom library which is in C and C++? How do you bring it to Snowflake? Because we were talking to many financial customers, and many of them told us that they have algorithms or native libraries which are homegrown and built in C and C++, and they're very, very confident on those libraries, and they are kind of the backbone to their business functions, and they really don't want to migrate those libraries to Python. So how do we bring in those workloads to Snowflake? Container services was our go-to choice. GPU, customized hardware. Now, customers who are doing computer vision today, they need GPUs. They cannot do high graphic processing in CPUs. They need GPUs. So if you know the Snowpark or the Snowflake warehouses, so we have the traditional standard warehouses and we have the Snowpark optimized warehouses, but then they're all backed by CPUs. We don't have GPUs out there. So what if I want to bring in a workload which is dependent on GPUs to Snowflake? Container services is my go-to choice. Re-platforming cost. Do I really, as a customer, do I really want to refactor my code or re-platform my code always? If not, if I do not want to do that, then I can wrap up my existing business logic in a container and bring it to Snowflake. Data governance. So many customers were using compute outside of Snowflake. So what were they doing is they were taking the data out of Snowflake, doing the compute outside of Snowflake. And the moment they were taking data outside of Snowflake, they were losing control of the data, because if the data leaves the Snowflake ecosystem, as an administrator, you really don't know what the data is being, how is the data used once it moves the container services or the Snowflake ecosystem. So that is the time, we heard our customers that, hey, what if I wrap up my existing business logic, which is running in an external compute, into a container? Can you host that container for me into a Snowflake? We reacted to that particular problem, and SPCS was our go-to choice. Customer opportunity. Managing high compute, because if you have a Kubernetes cluster let's say a managed Kubernetes cluster, even if you have a managed Kubernetes cluster, any Kubernetes admin would not disagree that it is really time consuming and it takes a lot of effort to manage your Kubernetes cluster. In that case, how do you minimize your operational expenditure? You can bring in those containers which are running on your Kubernetes cluster inside of Snowflake, and we do that heavy lifting for you. Right. Let's look at some of the challenges and the benefits. So I think some of it we have already spoken in the previous slide, so I'm not going to go all of it together. But then some of the most important things are like running workloads outside of Snowflake, data governance, complexity of platforms like Kubernetes and Amazon SageMaker, heavy refactoring of the code, because any migration exercise goes through a heavy refactoring of the code. And how many customers are really eager to embrace that particular challenge of refactoring? If not, then container services are the go-to choice for you. You can bring in your own language, no more networking. So if you are using managed Kubernetes, you will have to set up your networking on your own. If you do not want to do that, or if you are tired of doing that, let me put it that way, then bring in your containers to Snowflake, and Snowflake is going to do everything for you. And you can just concentrate on your business logic and give the responsibility of hosting and managing those containers to us. Data governance is one of the very, very important features that makes container services very, very attractive, because data never leaves Snowflake. And for all the security champions, this is very attractive, because it is all within the Snowflake ecosystem, and the Snowflake data governance instruments that we offer out of the box comes into action the moment we talk about data governance within Snowflake ecosystem. So Snowpark Container Services, just to understand, getting a psychological map of where does it sit. So you have the server-side runtime at the bottom, wherein you have your UDFs and stored procedures getting executed on your standard warehouses. Let me go to my laser pointer here, and you have your Snowpark data frame. So you have your ML data frames and the Snowflake data frames. But it is just next to the warehouses that the container services sits, because this is the next level of compute that Snowflake is offering in addition to the warehouses. What are services, jobs, and functions? We will look at it when we double click on container services in the next few slides. Right. So Snowflake container services, three primary benefits. Language and hardware flexibility. As I said, you can bring in C and C++ code. You can use GPUs. You are no longer limited to the languages that Snowpark as a platform offers you. Unified service experience. It is all integrated within Snowflake. So we are going to see what is an image registry. How do you upload data to an image registry, and you can refer the image which is uploaded to an Snowflake internal image registry and use it within your containers. So we will see that in action. Bring sophisticated data apps. Now, with container services, there were partners like Hex, who has built a complete IDE, a Snowflake development IDE or a Snowflake development IDE on top and hosted it within Snowflake using container services. So container services will open up an immense number of possibilities for you. Not just data, you can build an UI, you can build complete applications with container services, within container services. Right. What are the workloads that it supports? ML workloads. So when we started speaking about Snowpark, we boasted of the fact that you can build an end-to-end pipeline within Snowpark. Now, that is definitely possible when you are using the language of your choice, or the language that Snowpark offers. But if you're using something like R or C and C++, you are definitely challenged. And that is where container services comes into the picture to serve your ML requirements, wherein you can build ML models, not only in Java, Python, or Scala, but an in language of your choice, and create the entire ML pipeline within Snowpark. LLMs. You can bring open source LLMs to Snowflake. Now, those who have been following Snowday very closely, we brought in Snowflake's Cortex functions, wherein you don't have to actually bring in an externally available LLM into Snowflake. It is already made available to you as a customer within Snowflake, and you can just use them as a function. But then what if you are not? It's like, we're not going to bring in the entire list of the LLMs that are available, or the foundation models which are available in the market. We have brought in the very commonly used ones, but still, if you need a very specific ones, container services will be your go-to choice to bring in that very specific LLM. And how do you do that? We will see that in action. Optimized processing, we spoke about it. Applications. So yes, we are not limited just to data processing. We are opening the opportunities to build applications on Snowflake using container services. Right. Now that we have looked at the different options and why do we build, why do we bring in Snowflake container services, we will now double click on container services and we will see all the artifacts within container services. Okay, the first is your service. You will have to create a service. So what is a service? A service is a process which runs in your, so it's not very uncommon to the Kubernetes developers in this particular forum. So if you have been using Kubernetes, I'm sure you understand what I mean by a service. Service is a process which runs continuously in the background, ready to accept any input, and it will process the input and give you an output. So this is something which is continuously running. So you have to create a service. Service functions. So service function is nothing but when you do the inferencing. So if you have to do an inferencing, you actually call the service functions. And a job. A job is a scheduled task. So this is very different to a service. The service is something which is running continuously until and unless it is manually stopped, or there is an interrupt, an external interrupt is sent to the service. A job is something which comes into action for a specific purpose at a specific time, which is scheduled, does the job, and then it is taken off the shelf. The process terminates after that. Right. So this is a very interesting diagram from development to deployment. So how do we develop it? And finally, how do we deploy a service on Snowflake Container Services? So on the left-hand side, first is you have to build an image. So whatever the business logic you have, you build an image, an OCI compliant image. Now, the moment your image is created, what you do is you upload the image to the private image registry. Please note, this image registry is a private image registry, and this is not available. This is not like Docker Hub, or this is not like any other openly available image registry. This is an image registry which is very, very secured, only available to Snowflake accounts, and that is where you will have to upload your image. Once the image is uploaded, then from the image, you will and definitely we'll see what are the different what are the different artifacts that has to be there within an image. One of them is your YML file, which is nothing but the YML file to create a service. Now, once the image is uploaded and the image is instantiated, you create a container out of your image. The YML file comes into your picture, and based on the definition that you have provided in your YML, the service is created. You're first, and you also have to create a compute pool, because that compute pool either is going to be your CPU or it is going to be your GPU. You can, very similar to your size of your warehouses, you can define the compute pool. You can define what is the minimum number of node of your compute pool and what is the maximum number of node of your compute pool. It's very similar to how you have been using the Snowflake and the warehouses for till this time. And within your compute pool, you will have these three type of processes. You can have a job, you can have a service function, and you can have a service. And at the bottom of it, you have the interfaces with which you have the Python API. You can have the CLIs, the Snow CLI to interact with your container services. You have the private image registry. You have the instances, secured ingress and egress, because this is, again, data moves from the Snowflake storage to your containers. There will be data movement, both ingress and egress, but this is very secure. This is very different to an ingress and egress to an external system, because container services are within the Snowpark ecosystem. So even though there is an ingress and egress, it is very, very secured, and that is what makes our customers really, really happy. Service to service communication. So it is not that a service that I create can only interact with my data soak. There can be a service to service interaction. Like, for example, if I want to build a data application, I might want to use a memcache. Now, that memcache is something which is not available in Snowflake natively today. So what you can do is you can create a service to create a memcache in the format of Redis. Redis is a very common memcache that you use. And then you can build a service, a data application, which interacts with your memcache. So that becomes a service-to-service communication. It is not just limited to a service to your data store communication. Right. So this is how you create a compute pool. You create a compute pool, max node, min node, and the instance family. So you can mention your instance family as GPU or CPU based on your choice. But please remember, this GPU are all NVIDIA-backed GPU. And if you really don't GPU, you definitely want to watch out that you are not using GPUs, because it's going to burn a deep hole in your pockets. Create a service. How do you create a service? You have the maximum instances and the minimum instances, the compute pool on which the service is going to be hosted, and the location. And the location is going to be a stage, because that is where you have to upload your service.yml file. Where it is available today, it is available only on AWS US West today as we speak, because this is a private preview feature. But before we go public, it will be available on all the major cloud providers. Right. So image registry is something which you will have to, the first step that you will have to do is create an image, log into your image registry with your Docker login. So this is how you log into your image registry. right? Once the documentation is out, I think the private preview documentation is already out, but then the documentation is definitely going to be enriched with few, a lot of more use cases and a lot of possibilities. How do you get started with container services once we hit the public preview in coming few months? So you have to log into your image registry, and then you have to do a Docker push. So when you create, once you create your image on your local machine, you would definitely want to do a Docker push. You push it to your image, the Snowflake image registry, which is very, very private. Give me a moment. Before I forget, what I'm going to do is I'm going to start my Docker desktop in the background, and that will make things easy once we move to the demo, right? Right, back to the presentation. So this is how container service specification looks like. A very, 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 common way of talking or mentioning the service endpoints and the volumes. If you are used to YML, this is not very new to you. You mentioned the service, you mentioned the image, you mentioned the volumes that you want to mount, the endpoints, if at all there. It's like, okay, so let me tell you this: a service can have an external endpoint and may not have an external endpoint. It depends on the use case of that particular service. So if you need the service to be accessible by your by your users external to Snowflake, you can make it happen. You can mention those endpoints. If not, then you need not. Right. So we have spoken about service jobs. You can execute a job, and you can interact with the container application with your public endpoints and whatnot. Right. Moving on. Now, before we go into the demo, I think we have to spend some time on LLMs, because this is something which everybody is talking about. Every competitor of ours are talking about LLM in some way or the other. So if you have to, let's say you have an LLM which is very, very custom made for the medical industry, right? This is a hypothetical scenario. A very, very custom made LLM which is utilized in your custom in a scenario. That foundation model, if you have to bring it to Snowflake, how do you bring it in? You have to bring it in and in a container. Now, if you bring it in a container, and then you can fine-tune this particular foundation model within Snowflake without having access to any internet, because one of the most demanding questions that a customer is asking, that, hey, if I have to host an LLM within Snowflake, how are you going to ensure that that particular LLM is not having external access? Because not every enterprise is happy with the open nature of ChatGPT. While ChatGPT is great, but then it is open. But then enterprise today are not very sure whether they really want to leverage the services of ChatGPT. And whenever they are sure that they're not, they are turning to us and saying that, hey, how can I bring in an LLM within Snowflake and using the enterprise data which is stored already within Snowflake to fine tune my LLM, right? So this is how you can do it. You bring in your LLM within a container into LLM and into Snowflake, and use your enterprise data warehouse, which is built on Snowflake, to use that data warehouse to fine tune your LLM and then give it to your users. This is what I was talking about. This is a private preview feature, so you can bring your LLMs. You can also create native applications using your LLMs within container services. So I'm not going to deep dive into what native applications are, because that's not what the objective of this particular session. But for those of you who are very, very new to native applications, let me put a one-liner description of what native apps are. You can bring in you can develop a native. You can build in an application within Snowflake, and you can share that application with your customer, wherein the customer just needs to subscribe to that particular application, which you will be sharing to your customer, and the customer will have to just subscribe to that application, and the application can be shipped in totality to your customer account, where it runs and gives the customer all the benefits that the application has been built for, right? So you can bring in LLMs, you can design applications around LLM, wrap it up as a native application, and ship it to your customers. What are the GPU options which are available? This is what on the screen as we speak. I'm sure this particular, whatever things that you see on the screen, this is maybe a month old. I'm sure this has evolved, and that's a natural process for any private preview feature. Team is working on it, then this is continuously evolving, and I'm sure you will get much more options to choose from before we go public. As we speak, multiple customers have already created native applications and hosted it on Snowflake, backed by container services. The list is not limited to this, but these are some of the the most promising ones, most promising customers who have already built applications. Rather, let me put it this way: they have built native applications using container services, and they are already available on our Snowflake data marketplace. Right. So near-term improvements. The first thing that comes to my mind, and whenever I'm talking to any customer, is image scanning, because this is very, very important. And this is something which is not there as we speak, but then it is going to be there before we go public preview, right? The image that you build, the image that you upload to your image registry needs scanning, because there might be chances that you are getting an external image, and before you upload to your image registry, you definitely want to be sure that it is not having any vulnerabilities inside, right? So that's one of the most promising near-term improvements that my development team is working on. The second is persistent block storage. We are not there yet, but then we are working to get a persistent block storage within containers. DevOps integration, faster image loading, distributed training. These are, a handful that is there in the vision, and I'm sure we will be able to accomplish all of them in it. And it's like, this is the continuous improvement process for any product release, and these are there in our radar. Team is working on it. We really cannot promise a timeline when they will be there, but then watch out on our multiple marketing events. They will be there in this particular feature very, very soon. Customer stories. Now, we have been talking about a lot of customers, and I think this is one of the stories that we want to share with you. Now, this particular customer was not using any GPUs, or this particular customer was not using too much of an AI or ML. They're just using, containers in EKS for multiple years now, and as they were using multiple containers in EKS, they found that it is becoming a little difficult for them to manage that entire workload of containers external to Snowflake. So what they did is they brought those containers to Snowflake, and they are really happy that a lot of their operational overhead has come down once they have moved all those containers from EKS to Snowflake. Sorry. Yeah, Hex is, I'm sure, for those of you who have been following Snowflake or have been Snowflake users for quite some time, have heard about Hex. If you have not tried Hex, my sincere recommendation is to go and try Hex. You can just launch Hex with a few clicks of a button, and in the background, it is the container service that powers Hex. Hex is a great IDE to start coding with Snowpark. Right, it's time for a demo. Any questions that we can address, Sarita, at this point of time, or we are good? I think in the interest of time, we just have, I think, 10 or 12 more minutes. We will quickly wrap up the demo, and then we will come back to the question and answers. Right. Okay, so what have I done? There's a quick README file. I'm not going to go through all the details, but then what have I done? We have taken an open source model, which is the Whisper model. And for those of you who are new to the Whisper model, what does it do? It is a model wherein it takes input, a voice as an input, a voice command as an input, and it can give you a transcription in the language in which the voice has been recorded. So if you have something in Hindi, then it can translate it in Hindi. If you have something in German, if you have something in English, if you have something in Russian, it can do that, right? Now, what did I do? I have taken that, open source model. I have created an image out of it. As we speak, let's get into the Docker file. So what did I do? I'm using the NVIDIA PyTorch, this particular environment. I've done a pip install of the Fast API, the Gunicorn, then the OpenAI Whisper, right? This is something which is this is something which is available in PyPy, and that is the reason I have done a pip install. Now, whatever is not available on the PyPy, maybe you can get the source, the source repo and put it on Snowflake as well, or put it in wrap it up in your container as well. Now, once this particular Docker file, using the Docker file, I have created the image. So this is what I was talking about. If I go to my Docker dashboard, there is my Docker dashboard. This is my Docker dashboard. So you can see I have created an image, sometime back, the Whisper image, and it is 20 GB in size. At the moment I created this particular Docker image, what I did is I have to upload it to Docker registry, right? So if I go over here, you can see the push command that I applied. Okay, let me enlarge it a little bit for visibility. So what I did is I did a Docker build, and then I did a Docker push. So at this point of time, this particular registry or this particular image is uploaded to Snowflake internal image registry. Now, the moment that is done, I will have to create.
Sorry to interrupt you here. Increase the font size, please.
Okay, is it visible now?
Can we do one more? All right. Much better, much better. Thank you.
It becomes a little difficult for me to maneuver through the screen because it moves most of the pieces, but that's fine. Anyway, I'll manage. So
Thank you.
So we created the image. We created the compute pool. Okay, fine. Let me go to the execute. So what did I do first? So first is we create an image. We upload the image. Now, I'm not going to do the uploading of image right here because it takes more than 20 minutes. And in my internet connection, it took more than 20 minutes for me to, close to 10 minutes for me to build the image because it's 20 GB in size, right? And then once you have to move it, it took more than 20 to 25 minutes for me to move that 20 GB to my image repository. Now, if I show you my image repositories, this is the image repository that I have. You can see I'm going to use this image repository, RS Whisper image repository. Now, at this point of time, we do not have a command to peep inside this image repository and find out how many images are there. But then this is still a development in progress particular feature, and I'm sure we will be able to. We will be having some commands to do a double click on this image repository and find out how many images are there. But for your information, what I've done is I've already uploaded the image that I've built to this image repository. So now the next thing is show my compute pools. So I have already created a compute pool. You can see all the list of compute pools that have been created. Some of them are active, some of them have been suspended. Now they have been suspended because of inactivity, or they have been suspended because they are not in use. And let me tell you, these GPU computes are very, very costly. So if you leave them running, then again, you're going to incur a lot of additional cost, which you definitely don't want to. Now, I have created a cost called RS GPU pool. Let me do a describe of this particular pool. What you see is it is active. It has minimum of 1 node, maximum of 1 node. I don't really need a lot of compute. So that is the reason I have, I did not add a lot more nodes to this. I'm using one node cluster, but then I'm using GPU. because I tried running it on a CPU, and the time that it takes to do the translation, it's much, much longer than a GPU. And that is the reason I'm using a GPU out here. Now, if I deep dive on the left-hand side of this particular deck, what you see is the application. You see the specs.yml. This is the file which I was talking about. This is what, so this file has been uploaded to this particular stage location, Whisper app, and this is the image location. So this is the entire image path from my image repository. So you can see it is the Snowflake account, registry.snowflake.computing.com, my database, my schema, my image repository within my schema, and then my image name, which is Whisper app with a tag Whisper. So the service is going to be created from this particular image, and the source file, this particular file is there in the Whisper app. The next thing which I wanted to show you is the audio files. Now, which you see, these are all my inputs. These are the all audio files which I have uploaded to the stage. We will see that in action, how all these audio files are, a transcript of all these audio files are created by the LLM. If I go to the folder app, what you see is the web service. This is the web service. So what I did is I used Fast API because you need a mechanism to interact with your service. So how do you interact with your service? You need an API. So this is where Fast API came into the picture. We have created two endpoints. So the first endpoint is ASR, which is going to do the translation for you. And there's another endpoint, which is the detect language, which is going to do the detection of the language from that particular file from you. Core.py, this is the pure Python logic. This is you have the debugger, then you have the two functions. One is a language detection function, and the other function is a transcribe function. These are the two functions that I have written by using the LLM. Web service.py, I think we just looked at it. So these are the two most important files, the core files, the core.py and the web service.py. And if you look at my Docker file, I am, I am using those files over here. Let me move on to my stages, right? Show my stages. So these are the two stages that I have. I'm going to use the stage for audio files, and I'm going to use the stage for Whisper app. Let me go to audio files. So what do I have? All the audio files which I showed you over here on the left-hand side, the sample audio files, they have been uploaded to this particular stage before I came in. So they are pretty much, uploaded. You can see the last modified. So these audio files, we were doing a customer POC, and we got it from the customer. The customer was very, very happy to share these with us. These are all call center transcribes or call center recordings. If I go to the Whisper app, what do I see? I see I have uploaded the specs.yml, and this is the specs.yml, which is utilized by my service. If I go to my image repository, well, you cannot do that because this particular command is still not there. It's not in operation today. Now, so the service is up and running. Let me go to the service. The Whisper app, this particular service. Let me go to the service. What is the status of the service? The service is ready. The service is running. The service name is Whisper app, and the service is running on my compute. The compute which I created, the compute pool R is GPU pool. Right? Now, I have a select statement over here wherein I am, calling the function detect language. And all I'm doing is I'm sending a pre-signed URL for all the files which is stored in my stage. And I'm asking this particular model to detect the language in which the recording has been done. So if I run this one, what it does is it gives me the relative path, it gives me the pre-signed URL, and it shows me the language for that particular file. So you can see most of them are in German. I think I have some English as well. So yeah, the last three are in English. Now, this particular function. It was operated all within container services without any interaction with the open internet. Because if you look at this particular service, let's go to the service definition once more. If I go to my service definition, you will see that there are no public endpoints. There are no public endpoints over here, right? So this is all happening within container services. The next step, now that we have detected the language, next step, let's see that whether the LLM is able to transcribe the audio files properly or not. So I cannot do a testing, but then let me tell you, I have done a good amount of testing, and I could see that yes, the model has been able to, because all these voices are of different people. They're mostly German, but then they're from different people, different accents altogether. But then still, this model was able to successfully extract the script from, or transcribe all these messages. And here you see. Now I'm not in a position, I don't understand German, so I don't know how perfect they will be. But for the English ones, I did hear the recording, and I did compare them with the extract or the transcript that the model generated, and it was near to perfect, right? The still smell of old lingers, old beer lingers, it takes heat and all blah, blah, blah. So yeah, so this is how you can bring in externally or external models, external foundation models within Snowflake, host it within Snowflake, and use it. Now, for this particular demo, I did not fine-tune this particular model, but then there are, if you are following the Snowflake blogs, there are few demos that has already been created by our engineers, which shows how you can bring in an externally hosted external foundation model into Snowflake and fine-tune it, and then use it to a better for a better use. Fine, that's all I had to share this evening. I think we have just 4 more minutes before we wrap up, and let me have a look at some of the questions. Sarita, do you want me to look at some of the questions? Okay, answer live. Okay, I think let me unit store. I'm still looking, trying to find out where the container questions start. Okay, how web scrapping will work on Snowpark, how the installation of Chrome driver will work, and walk through scrapping on Chrome will be done. Can you guide on the steps? I don't have a reference, and I cannot even give you the steps. But then if you have been able to do web scrapping on your local machine in a container that is instantiated locally, I'm pretty sure you can do that on Snowpark and Snowflake as well. Can JFrog and other registry supported? No, this registry is very, very private to Snowflake. Answer live, can you provide the link to the Snowflake marketplace where vendors like Pinecone has built-in integrations? Well, I cannot provide you the link to the marketplace, but then if you have access to any Snowflake instance or account, you can readily go to the marketplace from there. And if you do not have, feel free to spin up a trial version. And from the trial version, you can readily go to the marketplace and look at those available services. About container endpoints, does that mean all containers are deployed on the same namespace? You can change the namespace as well, right? There are no restrictions. You can change the namespaces as well. And how do you do that? That is being driven by your the service definition file, which is the service.yml, the specs.yml file. That is where you have to define your namespace. Please share any link for the current sessions. I don't think the sessions are recorded. Not for processing. Java application is the consumption model, and my presentation layer is Snowflake. I don't know. I don't understand what is the question here. If the max file has a mix of languages, then how the language detector will work? Okay, I think you're talking about the input file. I don't think an input file will have multiple languages, because these are all call center recordings. And when a person starts speaking, I think we do speak in a single language in that particular session. But then, yes, if there are multiple scenarios, it's a good point. Need to explore. I really don't have an answer at this point of time, because that is something which I haven't. It's like I need to create an audio file with multiple languages and see how the LLM responds to that. Can you share a quick start to Snowflake Container Services with audio transcribe? I'm so sorry, we don't have any quick starts on Snowpark Container Services today. The reason is Snowpark Container Services are still in private preview, and you really need to speak to our product team to get it enabled. So if you have a very, very pressing requirement to try container services, do reach out to your sales executive if you are a customer, and we will take the problem statement to our the product team and get it enabled for you. But then, yeah, watch out till the time, watch out our marketing space. I'm sure container services will be in public preview very soon. And the moment it is in public preview, it will be available to all accounts. And I know a few quick starts will definitely hit the quick start deck. Why do you deploy the container services? Container services are deployed within a Kubernetes cluster, which is hosted within the Snowflake or the Snowflake ecosystem. So that Kubernetes cluster is very, very internal to Snowflake. Can we have a look at the demo repos? I don't think we can make it available, but yes, once the quick start is available, maybe I will publish this particular quick start as this particular demo as a quick start. Okay, which platform is this? Blue color. Oh, okay, this is Visual Studio Code. Okay, can you please share the tutorial with list of required with all the list of required step by step? I don't think we can do that, because as I said, as this is a private preview feature, developers are working on it, and we do not want to share a quick start at this point of time because it is subject to change. Not many things will change, but few minor things can change here and there. So we do not generally launch quick starts on private preview features, but then yes, do watch out for the quick starts the moment we go public. Can you please share a tutorial with the list of I think
let me step in real quick, Ritab, for all of you asking about the tutorial and access to the quick start. As Ritab said, this is still in private preview. Once we reach a stage of general availability, or right before that, we will publish resources on this. So do watch out on all spaces. We'll publish this on multiple channels. So you can reach out to us. You can follow Ritab on LinkedIn. He's available. You can follow us, me, anyone on the panel, and we will post about it. We are going to share a recording of this session. Just give us a couple of weeks. Next week is Diwali. So give us a couple of weeks. We will share a recording. But that being said, the access to Snowpark Container Services right now, as it is in private preview, if you're a customer and you have a very pressing use case, reach out to us. We'll connect you with the required teams and we can take it from there. But for now, this is a feature in private preview. I know we are all very excited about this, but bear with us for a few more weeks, and we'll get back to you. I know we are at the top of the hour. I really want to thank you, Ritab, for this amazing session. I know we have had way too many questions on Snowpark Container Services. Everyone has been super engaged. So thank you for walking us through these behemoth topics of Iceberg tables and Snowpark Container Services. For anyone else, if you have any questions, Ritab might just be around for addressing some questions in the chat.
Yep.
We will be moving on now to our next session, which is going to be around native applications. We will start off in another couple of minutes. We just want to take a breather. Let's take 2 minutes to just grab ourselves a cup of coffee, a beverage, and let's be back in another couple of minutes. We have Sumit, who's going to be walking us through building native apps with Snowflake. Thank you, Ritab, for this session, and thank you everyone who has stayed with us.
Thank you, Farhan, and thank you to all the audience for being very engaging today, and thank you for all the wonderful questions. Thank you. Bye-bye.
Thank you. All right, welcome everyone. Welcome to Discover. We are at day 2 of Discover. This is our last installment for the year. We'll be back again next year, but this is our last installment of Discover for the year. We have gone through some amazing sessions on iceberg tables, and we've gone through Snowpark container services. So if you're joining us from those sessions, welcome back. And for those of you who are joining us brand new, I welcome you very much to this session. This is on native applications, how you can build native applications on Snowflake. I wouldn't take much of your time because I know a lot of you have already been on this session. Remember, we are talking about some features that are not yet released. These are in private preview. So when the feature is released for general availability, there might be a few changes. It would definitely be better from what it is right now. But yes, we want you to know that we are talking about roadmap items, and there are some safe harbors and disclaimers that we'd want you to go through. That being said, we did Discover yesterday. Today is day 2. Today is the last day. This is the second last session. We have talked about ingesting data engineering, Snowpark. We have also talked about generative AI and LLMs. And now we are going to talk about applications. In particular, we are going to talk about native applications inside of Snowflake. So stay tuned. We'll have Sumit join us in a couple of seconds. Remember, this is a live event, absolutely free. Invite your friends. We highly encourage everyone to ask questions using the Zoom Q&A feature, either on the top of your screen or the bottom. We have an expert panel at hand answering those questions for you. And in case you're wondering where all of these amazing announcements are coming from and what is this Snowday that everyone is raving about, scan this QR code. It'll take you to the resources page. It'll take you to the recording. Just go watch all of these amazing announcements that we have come up with in the past few weeks. And if you have any questions, just reach out to us. Feel free to reach out to me, reach out to Sumit on LinkedIn, and we'll make sure we get all of those answers in for you. I see Sumit has already joined. How are you, friend?
I'm good, Farhan. How are you?
All well, all well. So we have Sumit, who is going to be walking us through building native applications with Snowflake. So this is an amazing session. I request all of you to be attentive and also ask questions in Q&A. So over to you, Sumit.
Thank you, Farhan. I'm going to go ahead and share my screen. Is my screen visible?
Yes, take it away.
All right. Thank you. Thank you so much. Thank you, everyone, for joining in, and welcome to the session once again. Quickly going through the agenda, we will go through an overview of Snowflake Native Apps Framework. And as you can imagine, there are two sides to the native application. One is that of a provider, the one who has come up with a business idea, has an intellectual property, and wants to monetize that on Snowflake Marketplace. So they want to sell this application which they have built. And then there is a consumer perspective. Consumer is the one who wants to use the application, leverage it for their business, get value out of it, and then they have to pay for it, right? So they want to consume it from the Snowflake Marketplace. So we'll look at both the perspectives on this overview. We'll look at few case studies of how some of the customers and partners have built these native applications. And then finally, we will do a hands-on for running with a native application. All right, so before I get deeper into the native application, I want to take a step back and talk a bit about data application, because native apps is a type of deployment architecture of data applications. Now, data applications are those apps which deal with large amounts of data, complex logic. So they are data intensive, and the primarily work of a data application is to kind of interact with data. So process it, let end users work on it and get the outcomes from that, right? So that's what we mean by data application. There are 3 different architectures to deploy these apps on Snowflake today. There is native app, which we will go deeper into. There is connected app architecture, and then there is managed app architecture. So let me start from right to left. I think that is simpler to understand. When we look at managed app, you can see here that it's end-to-end managed and owned by the provider. So the persistence layer, as well as the processing and interface layer, all sits on the provider side. Yeah. So provider controls and owns the data. The consumer just goes to the provider's portal for the application, works on the data and gets the output. Yeah, but it's entirely hosted by the provider. So the data is kind of in control of the provider, right? And there are customers who are okay with this architecture. They do not want the overhead of managing anything. So they just want the app provider to manage everything for them, right? And it works well for them. For the provider, it gets them the economy of scale.
they can have multi-tenants inside the single app and then cater to multiple customers, right? So it works well in that scenario. There are customers though who would not like the data to be sitting on the provider side. So then you can see the connected app architecture where the persistence layer or the data layer sits on the consumer side. So it's consumer Snowflake account where the data is sitting in. And then the provider has the processing logic and the user interface, which works on that data, right? So data sits in the consumer side. They pretty much own and control it, but then data has to move or go over the wire on the provider side to be leveraged inside the application, right? So again, it works for certain customers where they are okay to let the data flow into the provider app, manage and control it, and then have the insights come from the provider app. But again, there are customers who are not okay for data to go over the wire. They would rather like to have everything sitting inside their account, right? So more sensitive data, sensitive customers, etc. And that is where Snowflake native applications help us keep everything inside the Snowflake account. So if you look at the native application here, all the things are on the consumer side, the data or persistence layer, the processing layer, as well as user interface layer. All of them are on the consumer side, right? And the benefit is that the data is not leaving the consumer account. The application is coming and running inside the consumer account, right? So data doesn't go over the wire. For the provider, the good thing is that any consumer who is sensitive, they have sensitive data, they can just deploy it inside their account, right? And then it's easily available on the marketplace for both the provider and consumer. Now, this is not to say that one architecture is better over the other. All the three architectures have their own pros and cons. And depending on a specific business scenario and a requirement, you might want to pick one over the other. So native apps is the new framework which allows customers to keep data and app within the Snowflake account. All this processing and application logic gets encapsulated and executes inside the consumer account. This is currently in public preview and will be going GA soon on AWS. On the other clouds, this will be going into public preview in future soon. Right now, it's in private preview in other clouds. Yeah. So with that, let's go deeper into the native application capability. The native apps framework is essentially about building the application using the Snowflake capabilities, the primitives like Streamlit, UDFs, stored procs, and so on. You build the application and then distribute and monetize via the Snowflake marketplace. And then the consumers can go and discover the application, deploy it in their Snowflake account, and start making use of it, right? So that's typically what the Snowflake native app framework looks like. And as I said, let's look at it from both the perspectives, the provider as well as consumer side. Yeah. Here are a few examples of some of these native applications, all the way from the clean room, which allows customers to collaborate securely without sharing the PII data, to the connectors, which are available for ingesting data into Snowflake and then working more on top of the data. So there are a bunch of native applications available now. The slide is a little older. There are more apps available now. But I mean, again, you can think of any business idea about how you want to work on a data. And if you have specific intellectual property which you want to monetize, then you can build an app. And if you're a consumer, you can discover a bunch of these apps on the marketplace and start making use of that for your business. So on the provider side, there are three broad steps which the provider is supposed to do: build, distribute, and operate, right? So let's look at the build phase. The provider starts building the application. They have a business idea. They come up with the IP and the code logic to do that. They can use a favorite IDE like Visual Studio, PyCharm, etc. They can bring their CI/CD practices and so on, right? So they can build this in their environment. They develop the application using Snowflake primitives, like using Streamlit for the front end, Snowpark for working on non-SQL languages like Python, Scala, and Java. SQL anyway can run directly on Snowflake warehouses, data sharing for collaborating with their customers, and then telemetry to capture the billing events and tracing and logging of those application executions, right? Then they test and iterate on that application within their account. So the provider can create an app inside their account from this code logic, which we call application package. And then they test this via an application instance, which they create inside their account, right? So the provider can test, iterate on it. They can share within their same account for internal collaboration. So this is the build side of it. Once they have built it, tested and iterated on it, then the provider can publish it on the Snowflake marketplace or within the organization. So one scenario can be that I do not want to purely monetize this app, but maybe I have a large organization, right? There is a federated structure, a bunch of Snowflake accounts in my organization, and we want to kind of provide that to internal consumers, right? So this can also be an internal consumption use case where in a data mesh architecture, I publish my app and other consumers just consume that. So that's another scenario here. But you can either use private listing or public listing. Private listing means you share the app to specific accounts only. Public listing means that anybody on Snowflake can basically discover the app and deploy it on their account, right? So today we have 8,000 plus Snowflake customers. Any of them can discover and deploy it using the public listing route. When you do a public listing, then Snowflake reviews the version for security threats and scans the app, and then provides some kind of a tag saying, hey, this app is approved for public usage. If there are any issues, then Snowflake highlights that, and then you have to go through manual review, right? So there is a security scan happening for any app which gets publicly distributed. And then you can choose what kind of billing model you want to come up with. You can also create custom billing events so that you can come up with your own customized billing model. So providers can charge based on amount of data being ingested, the rows being ingested, the number of queries running on that particular data, and so on. So it's up to you to decide what kind of billing model you want to come up with for that particular application. Now, once this is deployed on the market, it is distributed on the marketplace and consumer has deployed it, then the provider can operate on it in terms of releasing new features and bug fixes. So you can come up with new versions of the same application. You have versions and patches. So versions are typically for major changes. Patches are typically for bug fixes, right? You're allowed to have 2 major versions at this point in time. So you always need to ensure that the app is consistent and compatible with the previous version of the app. On the other hand, patches are not limited. So you can have n number of patches. So you need to ensure that the app is compatible with previous versions of previous patches as well, right? So that's broad difference between version and a patch. You can make the new version upgrade on your side, and then Snowflake takes care of the upgrade on the consumer side. So as a provider, you do not have to worry about when will this upgrade take place for my consumer, right? So you're spared from all that work. Snowflake transparently manages those upgrades and in a non-disruptive manner. So consumers don't face any downtime when the app is upgraded, just like the Snowflake account. So if you today see the Snowflake platform, we keep releasing new upgrades on a weekly basis, but you never have to take a downtime for Snowflake, right? We never ask for a scheduled downtime. So in the same way, we are going to push these upgrades in a very transparent, non-disruptive manner. And then use the logging and tracing framework to troubleshoot these apps. There is also a concept of events table. If you're not familiar with that, Snowflake has come up with the events table concept to capture any events specific on a certain action, and that's called event table. So you can actually capture actions based on certain events inside the event table. So the consumer can share this back with the provider so that they can troubleshoot the app in a better way. So you can also ask the consumer to share the event table back to you with the specific information which is required. Now let's look at from the consumer side, right? We talked about the provider side. How do they build? How do they deploy? And how do they operate on it on an ongoing basis? On the consumer side, the consumer goes to the Snowflake marketplace and discovers the application. They are searching via a keyword or looking for a particular provider and so on. So they discover it. They can also evaluate this application if the provider allows to use it on a trial basis. So sometimes the provider may say, hey, I'll allow a trial for 7 days, 30 days, and so on. So consumer can evaluate it and then sign up for that particular application. The second part is a purchase and install for the consumer. So once they have tried the app, they are ready to pay for it. They can purchase the app also using Snowflake credits. So if you're a Snowflake customer and you want to buy a Snowflake native app, you can make use of your Snowflake capacity credits towards that as well, right? So you can actually say that, hey, I want to use my existing credits for purchasing this application. And then finally install and deploy this app in your Snowflake account. Once you deploy it, then the application starts to run. Other important thing is that any privileges which this application requires, like the application needs to work on the consumer data, it will specifically ask you for those permissions. And as a consumer, you have complete control on giving those permissions. Now you can see here on the screenshot that the app asks for certain permissions, you go ahead and grant those, right? So as a consumer, you know exactly what permissions you are providing to the application, and you have control of that all the time. So that's the final part of it. You give permissions to app and then starts to run on your Snowflake account, right? So that's the broad overview of Snowflake native applications. You saw the provider perspective. How do you build, distribute, and then operate on it? And then the consumer perspective of how you discover, purchase, and then set up and run that application. Let's look at a few examples here. So DTCC is a capital markets intermediary body for all the trading operations which happen between the buy side and sell side, between the market participants. They make sure that these transactions are honored and nothing falls through the cracks. So they need to maintain the risk exposure and come up with the portfolios to make sure that all these commitments are honored at the end of the day, right? So they have their proprietary algorithms to take care of these calculations, like what kind of liquidity do you require, what kind of portfolio I need to maintain, hypothetical modeling, and so on. Now, what DTCC does is they do these calculations, but their consumers or the clients do not know exactly how DTCC is calculating it, right? So then DTCC has to communicate to their client that this is the liquidity risk analysis and this is the kind of portfolio we require. So there is a back and forth between DTCC and the client. What they've come up with is they created this Snowflake native application so that this logic can be exposed to the consumer, and then consumer can run this on their data as well as some part of the data which comes from DTCC. So native applications allow you to work on the consumer side data as well as some data which is bundled and embedded inside the application, right? So only the specific rows which the DTCC requires to be shared are shared via the row access policies, and then the consumer can operate the liquidity logic on top of that. And then the final outcome is shared back with the provider, which is DTCC in this case, right? So there is bidirectional data sharing happening here, provider sharing with consumer and the consumer sharing with the provider. But then the business logic gets exposed to the consumer and they run that. One important thing to note here is that while the business logic gets exposed, the consumer does not see the actual code or the IP. The consumer can only execute that, the app as an executable, but the actual code behind that is not visible to the consumer, right? So the IP is completely protected for the provider. This is the kind of UI they built in for doing a hypothetical portfolio modeling and so on, right? This is second example of a company called My Data Outlet. They help customers do investment research from number of financial data sources. In this case, you can see there is S&P Capital, FactSet, and Refinitiv data. So before using the Snowflake native application, they were using SQL databases on customer premises, and each of the databases will have separate data source, and the MDO app instance will run on top of that. And then finally, analyst has to kind of work across multiple instances and get the intelligence out of it, right? So more work for the analyst, more work for MDO to deploy this app across different instances, and all of that change management and ongoing maintenance to be taken care of. What they have done now is with the Snowflake native application, they have deployed this inside Snowflake, and Snowflake Marketplace has the data sets from S&P, FactSet, and Refinitiv as well. So all they require is to publish this native app to consumer. The consumer then downloads and deploys this app, and on these market data sets which are coming through the marketplace are immediately available for the app to provide the insights to the analyst. So a lot more simpler for the analyst as well as for MDO to deploy and manage this application. So these are a few examples I wanted to talk about as to some possibilities in terms of the native applications. But again, there is no limit to imagination. You can think of any business idea in form of a data app and come up with a particular logic and deploy that. All right, so with that done, let's get into the actual hands-on lab. I will share the quick start link with you so that you can follow this along in your spare time later, not today, but you can follow this later as well. The quick start is pretty simple. So you can go through that and start making use of it. All right. So let me go ahead and share my my web browser now. I hope my browser is visible and my Snowflake console is visible. Philip, Sarita, if anyone, Farhan, if anyone can confirm that.
Yep, it's visible.
All right, cool. So let me first describe the scenario a little bit, and then we will go through the steps required to build this application. So here is my provider account here. You can see this in_demo19. This is a provider who has built this application. Yeah, and they want to now distribute it on the marketplace. So I'm going to show you the end product and then go through the steps of what we did to make this work, right? So this is your provider side. This is the data application. It is actually telling you that what's the lead time status for certain raw materials, like the finished products like ski goggles and so on, right? So a bunch of things which the data app is doing. The provider has built this, and then there is a consumer side. So this is the consumer account. This particular account, S Tandure, this is the consumer account, all right? So the same application is available to the consumer for them to run and then get the visibility out of the same data application, right? So these are the two sides of the coin, the provider side and then the consumer side of it. All right, so now let's get into how did we do this? How did we build this application? So this is the quick start, by the way. I'm just going to share the link for this in Zoom chat so that, or maybe Phil, if you, Fran, if you want to paste this link, you can paste it in the Q&A. All right, so this is the particular quick start, which you can go through in your spare time as well. So this is what the app does, right? So it basically builds some dashboards, lead time status, raw material inventory, supplier performance, and so on. There are 3 data sets here: order data, shipping data, and site recovery data. So 2 of these data sets will come from the consumer account. The order data and the site recovery data comes from the consumer account. The shipping data comes from the provider. So think of it like a supplier who has the shipping data, and they want to share the data as well as the logic of how they calculate the lead time and things like that, right? So you will see how we encapsulate this and then provide it to the consumers. So that's an overview about what the native application is doing. A bit of architecture and concept. This is how the native application work and architecture looks like. So let's say you have a bunch of SaaS providers offering their application code to you, then the consumer can have all of them running on top of their data directly inside the Snowflake account, right? So the provider only maintains, develops the code and then ongoing versions, but the actual execution happens in the customer Snowflake account, right? So you can see here native app providers, consumers, and so on. So Quick Start talks about that. And then here is the repo, the GitHub repository where the code lies. Again, this is public link, so you can actually access the GitHub link and see all about the code, the library, scripts, the data set, and so on. All right, so this is publicly available to you. Now, if you look at this repository, what we need to do is we need to maintain the same directory structure. So whatever directory structure the GitHub repo has, we will try and maintain the same structure on the Snowflake side, and I'll show you how we do that. All right. So you can see here are the data files. This is just a dummy data because we want to show you load the data and then show you the outcomes on the data, but this is just dummy data. And then you have manifest.yaml file, you have Python files, and then you have setup.sql, which basically sets up the Snowflake account. The manifest.yaml file is very important one. That is the one which outlines the dependencies the app has, the references to different tables, the artifacts, and so on. So you can see here how the manifest.yaml file looks like. There is a label, comments, and which is my setup script. The Streamlit instance for the UI, the tables which are referenced via the application, and so on. So in a nutshell, the manifest.yaml is keeping the metadata about this application. If you want more information about how do you create this manifest file, again, there is a public documentation available. This is how you can create the manifest file inside Snowflake. So there is a complete documentation about the entire native app development, which you can go through later on. All right. So apart from manifest, then we have the code files, like the Python files and the SQL files. So this just talks about one of the Python files, which has a UDF for calculating the distance using latitudes and longitudes, and then editing that file. Now, I have done some of this work already behind the scenes to save time in this quick start. But essentially, if I open my Visual Studio environment, you can see here, this is how my VS Code is looking like. So this is my Streamlit Python code for the front end. This is my udf.py, which is creating those UDFs. This is a setup.sql and so on, right? And then I have two versions, V1 and V2. We will start with V1, and if the time permits, I'll show you how to upgrade the version to V2 as well. All right, so this is how the repo looks like on the local environment. So let's say I built the application, I created the code, SQL code, Python code, and so on. And now I want to create this as a native app on Snowflake account side, right? So let's go through those steps as well. So this is my Snowflake console. This is the worksheet, which I go through. Now, before I start creating the application, since this app is already available, I'm going to go through an uninstall process. So you are going to see it backward, like the app is already installed. I'm uninstalling it, and then I'm going to do it fresh from there. So this is the instance on the provider side. I'm going to go ahead and install this. And then this is the instance on the consumer side. So I'm going to go ahead and uninstall the consumer instance as well. All right. And if I refresh my screen after uninstalling the app, you can see this app is available to me for deploying in my account because this is published by the distributor. So next step I'm going to do is I'm going to remove this application from the listing which has been created. So the app is gone from both provider side and consumer side. And now there is this listing which we have created in the provider studio. I'm going to go ahead and unpublish this listing so that consumers cannot see it. And then I'm going to delete this application, right? I'm doing this so that I can show you how do I do this from scratch. And I showed you the climax first, the end product first, and then I'm going to show you how do we build this from scratch. All right. So if I go ahead on the consumer side and refresh the screen now, you will not see the listing anymore because I have unpublished that from the provider side, right? So I cannot see this anymore. All right. So we uninstalled it, we removed it from the listing, and I'm going to drop this particular application package so that I can go ahead and start creating this from scratch. Yeah. So you saw the instance uninstalled. I dropped it now, and then I will take you through the steps to create this from scratch. Let me take a simple, maybe a Q&A break at this point before I go deep into actually creating and deploying this application, and just see if there are any questions, any doubts before we go deep into hands-on. Farhan, Sarita, any questions you want to push to me?
Just taking a quick look at the chat. I think we can continue along. Let's take a few questions towards the end. Yeah.
All right. That's all right. Cool. So here I'm going to create this application package. So very simple command, create application package. And then you can see distribution can be internal or external. So internal means I can only share it with accounts in my organization. External means I can publish it on the marketplace to any other account as well. I'm just doing it internal because it's a demo here. Once I create the application package, it essentially creates a database. So this is the database it has created for me. I'm going to make use of the database and I'm going to create a schema inside that. Then I'm making use of that schema. Now, the question in your mind could be that all these code files which are there on my local environment, how do I get them into my Snowflake environment, right? And how do I push those files? So if you're familiar with the concept of a stage, Snowflake has stages, which allows you to bring files into Snowflake, right? So we are creating a stage here, and we will bring all the code files into the stage so that we can create our application encapsulation through that, right? So we create the stage, we also create a virtual warehouse so that our application can make use of that, right? So we created the stage area. Now let's go ahead and upload the files from our local environment into that particular stage area. All right. So this is the stage. I'm going to open that. And I'm just going to see if I have any files here. So right now there are no files here. Snowflake has made it really easy to upload files into the stage and the tables. You will see that here. So I'm going to upload my source code here. So I'm starting with V1. And the first one is the manifest file. One important thing to note, as I said, is to maintain the same structure of the directories. So there was a V1 and V2. So I'm going to make use of V1 as a subdirectory inside my staging area. So the manifest gets loaded into the V1 directory, right? Now I'm going to upload remaining libraries here. Again, respecting the path structure here, I'm going to call this V1/libraries so that we are maintaining the path structure. Right, so you can see these files have been uploaded. I'm going to load one last set of thing, which is the setup.sql. And I'm going to put this under V1/scripts folder. So you can see this has been uploaded now. All right, so our code has been uploaded. The SQL, Python, and our manifest files have been uploaded to our code area. All right, let's go to the worksheet again, where we were actually playing around with this SQL, right? So we uploaded the code now. We need some data as well, because the consumer has to, the provider has to provide some data to the consumer. Also, we need a test data set so that provider can test the application. So we are creating this database called native app quick start DB. And then we're creating the schema. And then we're creating a bunch of tables, the order table and the shipping table, which should be on the consumer side. But for us to test it on the provider, we are actually creating this on the provider account. And then site recovery. So the shipping data will go to the consumer. The rest two data sets will remain locally available to us. All right, so these are the tables we have created, but there is no data inside them. So some of you are familiar with the copy commands, and we can use copy into to absolutely load the data. But then I want to show you how do you upload the data from the UI as well, right? So let me show you that. So this is the table. I have opened that, and I can just click on the load data button here. I can go ahead and upload this data file here. So this is my orders table. This is the orders.csv. I'm going to upload this file. And there are a bunch of options in terms of what's the file format. So we have delimited files. The only thing I need to change here is this double quotes. Rest of it is the default setting. So you can see very quickly, we have 1,000 rows uploaded into Snowflake table, all from UI, right? So I didn't have to execute any SQL for that. I'll go ahead and do the same thing for the other tables as well. So this is manufacturing.shipping. I'm going to upload the shipping data here. So another 1,000 rows loaded into the shipping data. Yeah. And let's finally look at the site recovery table. If a site is not available, how long will it take me to get the supply from other place, right? So that's a site recovery data set. And again, this is the only setting I need to change. So these are 249 rows. So we have loaded some dummy data into our tables so that we can share with consumer and also test the application locally over here. All right, so I'm going to close this app. Cool. So we have the data now in the tables. Now we are going to create some shared content. This is the data which provider wants to make available to the consumer, right? So if you're familiar with the data sharing concept, you share the data via data share. But in the concept, in the context of native application, you create a particular schema and then provide permissions to application as a share so that it becomes available to the consumer. So this is the database I'm going to create for the shared content. And I'm creating a view here. You can see this is manufacturing shipping view. All it does is does a select star on my underlying manufacturing shipping table, right? So the same content, but it is available in the content schema now, shared content schema, so that I can provide permissions to my application on that, right? So I'm granting usage on the schema. to a share in application. This is how we provide permissions to the app on the content which needs to be shared, and share reference usage, select on view permissions to the application, and so on. All right. So we provided the permissions required to the application. Then we are gonna create the particular version, which is the V1 version of this application package. This is the time when it is going to look at the code. So all the code which we uploaded, when we add a version, this is when Snowflake tries to create, tries to bring all of that into application encapsulation. Yeah. So you can see it says V1 and patch 0. And now in order for my consumers to access this version, we're going to set this as a default release directive. So release directive allows us to set a particular version as a default. So whenever consumers discover the app on the marketplace, they can actually use that particular version by default. Right. So we have set that up as a release directive. Now I'm going to test this application locally in my environment. So I'm going to go into the particular database schema and then creating an application instance. So all I'm doing is creating the application instance from the package using version V1 patch 0. So this is called as a development environment, dev mode, because I as a provider is going to test the application in development mode. I will run, iterate on it, and so on. There is also a debug mode available. So you can alter the mode as a debug mode so that you can get more functionality on it as a provider. All right. So our application instance has been created now. And these are the packages which we have. These are the applications which we have, and so on. All right, so we got a V1 of our application created and deployed inside my provider account. If I now go to my apps part of the UI, you can see that this application got installed. And if you see the packages, because I'm a provider, you can see this is the package I have. I can go click on the package. You can see there is a V1 here, patch 0 here available. All right, if I click on this application, it should now start running in my provider account. I just want to test how the application is working. And you can see the Streamlit UI is working now. It's performing certain steps like connecting to the server, loading Streamlit application assets, and so on. And you will notice that it asks me for permissions on my tables. So it's saying that, hey, I need permissions on this orders table in order for me to work. So you go ahead and say, hey, yes, I'm okay to give you permissions. It's asking permissions on another table now, which is the site recovery table. So it asks you permissions only on the 2 tables, not on the 3rd table, because the 3rd table is already inside the application schema, because that's a shared content, which we got from our shipping table, right? So it doesn't ask you for permissions on the 3rd one, because that's coming directly from the application schema itself. So you can see the app instance is working for me now on my provider account. I will go ahead and create a listing now so that my consumers can discover and consume the application. So I'm creating this listing here inside the provider studio. I'm going to call it native app quick start. I'm going to select only specified consumers because it's a private listing. And I select the package as the listing content. And I'm going to do some description here. Here is how you add the consumer accounts, right? So you have to follow the pattern called organization.account name, right? So if you're familiar with this, you know that Snowflake has org structure and then there is an account name, right? So you can follow that particular format to add the consumer accounts. In case you're creating a public listing, you don't have to worry about this. This will get published to all your consumers automatically. So you can see my listing is live now. It's available to S. Tandure in the organization SFSE APAC. So now I come to my consumer side. So this is the consumer account, SFSE APAC S. Tandure. I go and refresh my apps side. I can see that this application is available for me to deploy. It asks me which warehouse I want to make use of it and what do I want to call it, application instance, right? So I go ahead and then click on get. It starts to deploy the application on my consumer account. All right, so it's saying installing. I also have my email ID given here. So once the application is installed, I get an alert saying your application is installed and ready to be used. So let me go to quick start by the time this gets installed and see any other steps which I should explain here. So I talked about the code files, making it part of the installation script, which is the setup.sql. So this is the installation script, and you kind of add that function here. All of that has been done already. And then if you recall, I created the application package by using create app package command. And then I went into the particular database and schema to create the stage on which we uploaded the code files. Right. So this explains you how we upload the code files onto the staging area. Then we created the tables for uploading the dummy data. So we had manufacturing shipping table, and then we uploaded the file using Snowsite. Of course, we could have used the copy into command as well, but we chose to use the UI route here. And then we added data to the application package by using the shared content schema. And then we gave permissions to the share inside application package. All right, so these are the steps we have followed already. And then we created a particular version. We could have done this from the UI as well. This quick start tells you the UI steps, but I actually ran this through SQL commands, right? So you have both options, use a UI or use a SQL command. Then uploaded the test data on remaining tables, and then tested the application by creating the create application instance here. So now I'll go ahead and see my consumer account and see if this app has been installed already. And you can see the app is installed in my consumer account. This is my consumer account, right? I can go ahead and click on it. And now the consumer account is running this application. There is particular data set which is internally inside the application package, but then there is data on the consumer side which the application requires access on. So it's asking the permissions on the consumer account that please provide me permissions so that I can make use of this data. All right, so that's one table, and then I'm gonna just refresh it once. And it asks me permissions on the other table as well. So you can see these two tables are coming from my local consumer account, but the third table content comes from the shared content schema inside the application package. And now this application is working on the consumer side. All right, so we deployed the application and it's up and running on my consumer account. I think all in all, it took us maybe about 20 minutes to go from scratch to deploy and get it up and running on the consumer account. Of course, the code was already written. So that's the part where you kind of put your IP into the application code, but then the rest of the steps were pretty fast, simple, and straightforward. All right. And if you see the quick start, you don't see these steps over here. These steps are something which I followed additionally to show you how the end-to-end flow looks like from the provider to the consumer. So you can consider this as a Diwali bonus. We have Diwali coming up. So this is an add-on, how to create a listing, how do you show this to how do you discover this on the consumer account and then deploy it. All right. I have one more bonus because we have some time left. And that bonus is how do I create a new version of this application? All right, so I'm going to close some of these tabs. And I'm going to go to my worksheet where I was actually creating this, right? So this is my quick start worksheet. What I'm going to do now is do a version 2 of this application. All right, so I'm going to upload the code in version 2 folder. And if I go inside my data, and my app package was under native app quick start package. This was the stage. I'm going to upload a V2 version of the code now. So I'm going to browse and say, hey, this is the source code. This is the V2 code, the manifest file, and I'm going to put this under V2 folder, right? So I'm going to follow the same structure, just like my V1 structure. All right. And then we have libraries here. V2/libraries. You can see how quickly we are able to perform some of these steps. So the UI is also very intuitive. And then finally, the scripts folder where I'm going to upload my setup.sql. All right. So that completes my V2 version code, the manifest, libraries, and scripts, and so on. So I'm going to go ahead and then upgrade my application to version 2. So I'm going to say, hey, add version V2, and then create a particular label. All right, so it's going to create a V2 version of my application. It's looking at the code content now, and it creates a version 2. If I run a show version command, you can see the label which I added. You will notice that there is also a comment which I did not specify in my command, but that is visible. How is that coming is from the manifest file. So if you go and open the manifest file, you will see that there is a comment here, the first version of the application, and this is my V2 where we have this comment. So it automatically picks this up from the manifest. All right, now I'm going to run an upgrade process as a provider. I want to upgrade my application to V2. And this is because I'm on the provider side, I'm doing this manually. But if you're a consumer, you don't have to do this. The moment I set my default release directive as V2, the consumer application gets automatically upgraded to V2. All right. But because I do not have time here, we need to wait for some time for the V2 to get propagated to the consumer. I'm doing a workaround. I'm going to do this manual upgrade on the consumer side. And there is a typo here. See, I'm probably not in the right schema here. So native app quick start. I think I had a typo there. So I'm just going to do an upgrade here. So this was my version 1, and this was where are my ski goals. The only change I have made is I've changed this title a bit in the V2. That's all the intellectual property change I have done there. So let's see, when I refresh my browser now, I should see the V2 version of this application. And you can see that my title has been changed. It says, please tell me where are my ski goggles. So now my instance is running from the V2 version instead of V1. Right. And same thing should happen on the consumer side as well. So if I go to consumer side and go ahead and click on the applications and run this, you can see that the title has been changed here. So it's running from V2 version. All right. So you saw how I was able to upgrade the version from V1 to V2 on the native application. All right. So that's all I did from the worksheet side. You also have some of the things which you can do from the UI. So this is the UI, and you can see this is the package. There is a V1, there is a V2. Earlier, you could see only V1, and this is the V2. So you can see the manifest file. You can see here, you have options to add a patch via the UI as well. Right. And it doesn't allow me to add any more versions because I can only have 2 major versions. So that's why you can see only V1 and V2. Otherwise, I should see an option called add a version there. All right. So I can go ahead and drop this, but then it tells me that this is being referenced right now in the release directive. So I cannot drop the V2 version of this, right? So it prevents you from dropping the latest version as well over here. All right, so I think we are close to the 1 hour mark, and we have some time to take questions as well. Farhan, Sarita, any questions you want me to take?
Right. So there's one question here from Kunal who asks, how long does this process take? How long does it take to finalize app review?
Usually the app review process is fast. So if my distribution is external, I can expect that to happen in few minutes. It's an automated security scan. Only if the application fails the security scan, that's when it goes to the manual review, right? So the automated review is pretty fast. Again, if you want more information about this, you can actually refer to the documentation here. It talks about running the automated security scan here. So it talks about what are the security requirements, how do you open this for security scan, and so on. So I can show you actually, if I change this distribution to external. So now I'm changing my distribution to external because I want to make it a public listing. And now if I run this show version command, it says review status is in progress, right? So if I run the same command after a few minutes, you will see this review status is approved. And I was doing the test before I came to the webinar, and I could see that this took probably maybe a couple of minutes to move into the approved stage. Any other questions, Farhan?
All right. I don't think we have a lot of questions here. I'll once again, I'll encourage everyone to ask questions. I know this is a lot to take in. There are a lot of resources. We've already shared the quick starts guide with all of you in the chat. If you don't have that link, just let us know. We'll share it once again. But just remember that there are a lot of resources on snowflake.com. You can go to quickstarts.snowflake.com to explore all of the available quick starts that we have. There is learn.snowflake.com and community. So if you want to join chapters and, if you want to be a part of the community here in India or in the, in the region that you're in, just let us know and we will send out all of these resources. I know there were some questions on the session being recorded or not. Yes, it is. We'll be sharing the link to the recording with you in a couple of weeks. As Sumit said, he gave you a Diwali bonus as much as we could. And post Diwali, we'll share some of these resources with you. So just bear with us for some time and we'll share these resources. In the meantime, so if you want to take this,
Yeah, just to recap, what you saw is how do we build native application using Snowflake capabilities. Then you distribute and monetize via Snowflake Marketplace. And then finally deploy the application in consumer Snowflake account while the provider has full control of their intellectual property. So that's a summary of native application framework. The data doesn't have to move out consumer Snowflake account, so complete security on the data side. Here are some of the links on the resources which Farhan and team will share with you. So the quick start, which I was referring, there is also a tutorial, which is another, you can treat that as another quick start. So you want to play around with one more example. The tutorial goes through that step by step. The documentation, which I was referring to, there is also bootcamp videos where you can go from conceptual understanding all the way to the detailed deep dive of native application. There is a user forum where you can ask questions around if something is not working and you want some troubleshooting assistance. There are other customers who are also there on the user forum, so you can get the questions answered. And the entire commands reference of whatever I was running, the application package, the create application, and all of that is available. So I can quickly show you how those web pages as well. So this is the quick start, the GitHub I was talking about. This is the additional tutorial, another bonus. So this is another tutorial you can follow all the way along, like creating the application files, creating the package, uploading the files, adding the logic, data content, and so on.
If you're sharing a browser window, it's not visible. So
I'm so sorry.
Yeah.
Is it visible now?
Yeah.
All right. So this is another bonus tutorial I was talking about. So you have the entire step-by-step process, what you need to follow in terms of creating the application files, the package, uploading it, adding the logic, and so on. So it goes through, this tutorial has the publish and install instructions as well. So this is more complete. Yeah. And then there is this complete documentation page for the developer. So this is the developer documentation reference, and on the native apps, you can refer to this particular section. And then you have the bootcamp, which is the native app bootcamp. And you can see all the way from introduction of the native apps all the way to monetizing the native app. Bunch of videos available here, and they are not long. So you probably need a couple of hours to just go through all of them together. This is the forum. This is the community where you can raise questions and so on. Yeah. And then the SQL commands reference for entire native application framework is available over here. So in a way, this docs.snowflake.com is your Bible, or whatever you like to call it. All the documentation around Snowflake platform and various capabilities inside this docs page. Right. So the developer section is over here. And there are other things around Snowpark API, Snowpark ML, etc., etc. So that's right. Resources run through And I think I was trying to show this Visual Studio, which was not visible to you on screen because I was sharing only my browser. So this is the VS Code, and you can see all my files here, the Python files, the SQL files, the manifest file, and so on. And this was the comment I was referring to, and various references, the logging level, tracing level, and so on. Right. So this is how the actual code files look like. All right. Any other questions before we wind up?
There is one question from Kunal who asks, what is the upfront fee a provider has to pay to Snowflake to publish the app?
You basically you need a Snowflake account. So you will need an account to develop this application, and whatever credits are required in order to develop and test the application, that's the only thing you require. There is no bare minimum fee. We encourage you to sign a capacity contract with us, which can be as minimum in size as you want. And you need to sign up as a provider. So basically you need to be part of the partner program so that your applications can be published and available to the consumer. So there is a bit of sign up process required. And hence we encourage you to become part of the capacity contract. But again, there is no minimum credits required. It can be as minimum as required for you to get the application up and running, test it, and then publish it to the marketplace.
All right. Once again, everyone, as Sumit said, the Snowflake documentation is your friend, your closest ally. If you want to learn more about the platform and all of the other things that it has to offer, just go to the documentation. It is a treasure trove of information. You'll find everything in there. If you're not able to get your answers through the documentation, reach out to us. You can reach out to Sumit on LinkedIn. You can reach out to me. You can reach out to any one of us, and we'll connect you to the right people and teams that will be able to get those answers for you. Now, I think with that said, we are
a few more questions which Sarita is going to answer live, so I can take them up. I think we have a good amount of time left. So
yes,
there's a question on sharing the resource links. Yes, we are going to do that. We're going to share. There's a question. There are lots of capabilities in Snowflake. If I had to define Snowflake, how can I define this? A database, a data cloud platform, or what? I think that's a very good question. I think 5 years ago, if you had asked this question, most of the people would have answered that it's a database. It's a data warehousing, and there is a Snowflake acts as a database for data warehousing, right? So you create a data warehouse on Snowflake. That was the answer maybe 5 years back. But all the founders had the vision to develop this into a much holistic data platform. And that vision was there from day one. And the step one was to create a warehouse which was simple to use and which could cater to big data and all types of data, all types of workloads. So if you see in the last several years, what Snowflake has added is all different types of workloads. So it's not just a data warehouse, data lake, data science, data engineering, and data applications. If you look at data apps in particular, the data is pretty much meaningless if we don't interact with it in a simple manner from a business user standpoint, right? The data is just a bunch of tables and so on. But it is the applications which provide the end user the power and ability to understand and interact with the data. And hence the data apps become very powerful part of the overall workload spectrum, which Snowflake wants to address. Yeah, so it has evolved into a much more holistic platform. And now the terminology we use for it is data cloud, because you're kind of collaborating on the data and application on this entire super cloud called Snowflake. So it's another layer on top of the cloud on which you got all the data content, you got all the application content. There is a side of provider which are publishing, creating, and then there is a side of consumer which are consuming and leveraging it for business purposes and so on. So it's a networking effect. The way to look at it is this is becoming like a cloud in itself, a super cloud on top of the normal public clouds, where you create a network for data and applications. You get your insights with all the analytical workloads, and you basically collaborate and get more and more value from your data. So the only term, one summarized term is data cloud. But if you distill it down, it is consisting of various workloads like data warehouse, data lake, data science, data apps, and all of that. And then if you look at it from a persona standpoint, you have data engineers, data scientists, data analysts. So all those personas you can imagine in the entire data spectrum. So single platform for multiple data use cases is what I would say.
Great. There is one more question from Kunal who asks, on top of that, the Snowflake keep a margin.
Yeah, so
I
I don't have the, I mean, it's a very minute number. I don't have the exact number. On the data sharing side, we don't charge anything, but for the apps, there is a small margin. It's in lower single digits. We can get you the exact number, but there is a small margin kept by Snowflake. So it's not 15%, it's much lower than that.
Yeah.
I can see 22 questions have already been answered by Sarita. So I think I can see quite a bit of them have been already answered.
Yeah. There's one more. There's one more question that has just come up from Gautam, who asks, "How are these data apps different from these visualization tools, such as Tableau?" And that's a very good distinction. That's a great question, Gautam.
Yeah, absolutely. And I would say visualization tools are a kind of data application. You can think of BI tools as a kind of data application, right? Because all they are doing is working on top of data, giving you insights, giving you visualizations from that. But the data apps is not just about visualizing the data. It's also about running whatever logic I want to run on that. So it's not just about giving the visual rendering of the output, but let's say I have a proprietary algorithm, like in case of DTCC, they had a liquidity exposure logic which they were running on it, right? And which they wanted to expose. Or it could be a machine learning or LLM application as well. So I think I forgot to talk about LLM, and I think some of you might have been there in the container session before this. You can pretty much create an entire LLM app on top of the data saying, hey, how do my end users interact with the data? It might be an unstructured data, it might be structured data, but I want to create an application to allow them interacting with the data, right? So you can build LLM, AI, ML apps as well. Ultimately, the data apps allow the end users to interact with the data, see the output, run some proprietary algorithm on it. So I would say data apps is more holistic compared to visualization tools. You can even think of the ingestion like taking data from sources, bringing it into Snowflake. So if you look at native connectors, they are also native apps. Now they are not doing any visualization. All they are doing is they are talking to the source and bringing data into Snowflake. But we still call them as native application because they are operating on data. They are operating on top of Snowflake directly. So I would say the spectrum of data apps is a little larger than just the visualization tool. And visualization can be one type of data application.
Great. Thank you so much. All right. There is one question from Raman who asks, do you support a freemium model for new apps? Idea is margins start kicking in when we see consumption. So I'll let you take a stab at this, Sumit.
So I think the way I look at this, and probably the way I understand this, is the freemium model is more for the provider to come up with. So like I said, there is, for example, they can come with a trial period and say, hey, I will not charge you for 7 days or 15 days. I will charge you only after a certain period of time. So the provider can come up with the freemium model they want to do. They can say, hey, I will allow maybe 1,000 queries to be free of cost. Only after 1,000 queries, I'm going to charge you for this. So it's up to them how they want to monetize that and come up with the freemium model. Yeah. So
right.
Absolutely, the provider can do that.
Yeah, and just so you know, Ramana, just so you know, we support different types of pricing models. So if it is freemium, where we are providing limited entry level offer, for a basic level of service. This could be for students or developers, researchers that are exploring the data. Freemium is a model that we support. We also support fixed fee model. Wherein your data and information is not changing over a very long period of time. So we support fixed fee as well. There is subscription-based models wherein if there is continuous use, you want to have your consumers subscribe to your data. We can support that as well. And of course, there is usage-based. So rather than an upfront fee or a periodic payment, the consumer would pay at the time of use, and then by either a human intervention or through an application or through an algorithm, we'll step in, and then you'll be able to get that usage based fee as well. So just so you know, we support all of those pricing models. Of course, if you want to know more information about this, we can definitely have you speak with our marketplace leads. They'll have a lot more information on this, but just so you know, we are very flexible on the pricing strategy. So be it freemium, be it a fixed fee subscription, or a usage-based model, we support all of that. And then, of course, it depends on the target audience whom you are targeting. As Sumit said, a part of it also depends on the consumers that you will be targeting. So I hope that answers your question.
Yeah. And like I said, like the provider can come up with any kind of monetization model. Snowflake is just a platform for them to put that model on the marketplace. So the pricing model is available on the marketplace and consumers consume it. So it could be per month basis, per query basis, mix of multiple things and so on. So it's totally up to the provider to come up with a particular monetization model.
Great. Let's see if we have any more questions. I think we are almost done with this. First off, I really want to thank you, Sumit. You've covered not only native applications, but also given everyone a really nice Snowflake Diwali surprise. So thank you so much for that. What we're going to do now, I'll just want to apprise the audience of what's coming up next after Discover. This is the session after this is the last event, the last session that we have for Discover. This is our last installment of Discover for the year. So I'll just tell you what we are going to be doing next, where we are going to be next. And if you want to meet with us in person, where to find us, where we'll be, and all of that information will be in there. So first, let me thank Sumit. Once again, thank you so much for this session. There were lots of great questions, and I know this is a new topic for the audience, and we uncovered a lot of sort of myths around applications, and we sort of created a definition around how we define applications. What kind of models do we have? The managed app, the connected app, the Snowflake native app, how all of that differs. So we have covered a lot of ground in this session. I'll like to share my screen real quick, let everyone know that this is coming up. Build is our developer focused event. It's happening virtually on 5th and 6th of December. So if you want to join us in here, we'll do a lot of hands-on demos, labs and such. So if you want to join us and learn more about LLMs and Gen AI, please do. And we'll see you very soon. Of course, we have a lot of friends here for you at Snowflake. That is quick starts, learn, and training. So if you want to get certified, get some upskilling done, education done. So we have all of those resources up and ready. If you are from India and you want to become a part of a community that meets up quite regularly, we are going to be meeting next month. If you're in Delhi, Bangalore, and Pune, you can join the chapters, the user group chapters for these 3 cities. And if you're joining this session from Korea, Singapore, or any other place, even from Japan, we have established chapters in your country. It possibly could be in your city as well. So go to community.snowflake.com and search for your city. It should be there. If not, reach out to us and maybe we create a new chapter for you. So please let us know if we can be of any help. And yes, for some of you who asked about training and certifications, we are going to be providing a free, absolutely free of cost training workshop for all of you. You will get a hands-on badge once you've successfully completed this workshop. We call this Snowflake Ascent. It's run by our education services team. We're going to be doing this virtually on 8th of December. We'll send out an invite to all of you, so you don't have to worry about it. But just in case if you want to grab that QR code, it's right here. It's for the entire region. If you're joining from, so if you want to join from Singapore or from Japan and you feel that the Australia, New Zealand time zone is going to suit you, please join that. If you feel if you're joining from India or from Sri Lanka, you can join the India time, and we'll have a fun day. So that being said, this has been absolutely wonderful. We are now going to take let's say a 10-15 minute break, because we've been going on all the way from the morning. We've been talking about native apps. We've talked about iceberg tables. We've talked about Snowpark container services. So let's take a breather. Let's be back in another 15 minutes, 2 o'clock India time. Let's be back. If you're joining us from Singapore, that is going to be 4:30 p.m. Or if you're joining us from Sydney, which I'm assuming you're not. So joining us from Sydney, that's 7:30. And if you're from Korea, Seoul, that will be 5:30 p.m. for you. So we'll see you in another 15 minutes. Let's take a short break and let's play a video.
welcome Snowflake Senior Vice President of Product, Christian Kleinerman.
Thank you for being here with us. Thank you for joining in. The most important aspect of what we do is we take complex technology, complex problems, and we make them as simple as possible. We have evolved the data cloud, not just from additional workloads and capabilities, and not just from collaborating on data, but we've also gone into collaborating with applications. And we have a number of interesting announcements on how the data cloud keeps getting more powerful and more exciting for all of you. Today's announcements have been bucketized in 3 categories. First is a data foundation. Second one is accelerating AI success. And the third one is going to be how do we scale with applications.
We chose Snowflake mostly because of speed and cost, but that was a bit of a surprise to us, exactly how inexpensive it was to run Snowflake.
We expanded Snowpark to include Snowpark Container Services, which is the secure hosting of Docker containers within the security perimeter of Snowflake. And it is very significant. It enables all sorts of interesting computation and business logic to run inside Snowflake. It has generated a huge amount of customer and partner excitement, and we are ramping up the number of customers and partners that have access to the point that we are introducing a public preview of Snowpark Container Services very soon. But one of the aspects that we are most excited today is how we want to bring AI for everyone and simplify the use and the experience of AI. And to do so, we are today introducing Snowflake Cortex. It is a managed service that lets you do serverless inference, and it gives access to industry-leading AI models. We're focused on ease of use, and we're focused on cost effectiveness. Effectively, what we're working on is helping you build generative AI apps and simplify the process of building AI apps. How do we enable you to chat with your data? And it starts with a function called complete. And complete is just the way to interact with a model, open source models, and the most common one is Llama 2. And imagine we're making it so easy that you log onto Snowflake and Llama is there. You want to build an app and Llama is there. You want to create a chat experience with your data and there's a Llama there. We're also introducing Snowflake Copilot. It starts with writing SQL. So maybe you want to write a natural language prompt and get some queries written for you. Or maybe you want to use conversation to refine queries that you already have in worksheets.
Today, I'm a data scientist at a ski gear manufacturing company called Ski Gear Co. And we want to understand why we've been having a big spike lately in customer complaint calls. I see we have a couple fields here, including the language of the call and the transcript itself. So just browsing through is helpful, but maybe now I can use Python to create some plots and charts to quickly identify the patterns of these calls and see what's the trend here.
You know, I tell people that I feel like a kid in a candy shop again in terms of just how much change and how much excitement that there is.
When you think about large language models in combination with managed services like Snowflake's Cortex, you can really give a lot of companies, small, medium, large, the ability to work with their own data and customize models in a way that they couldn't before with a lot of closed approaches. And I think we're going to see in 2024 lots of really innovative, exciting ideas that are going to emerge.
Now that we have all of our data in one spot, we can do machine learning much easier. We are starting to use machine learning to do some predictive insights, some predictive forecasting.
We want to help with the whole process of deploying, distributing, monetizing applications. And that's why we evolved our data sharing and collaboration capabilities into what is now the native app framework at Snowflake.
Native Apps has empowered software providers like MDO to deploy our application directly in Snowflake. We've already marked substantial milestones, such as successfully onboarding a top 10 hedge fund, and we're already on track to attain annual recurring revenue of $1 million by year end.
Let's take a look at how we can help you bring those custom applications into Snowflake, where they can take advantage of all the different features, including large language models, but also the security, the governance, and the compliance that makes Snowflake so special. What we want to do, though, is take the new summarization features that we built a few minutes ago, and we want to bring those directly into this application. The application itself, all the state and the large language model functionality are all hosted entirely inside Snowflake.
Exciting Snowday so far.
Yes. Amazing.
Yes, and there's lots of excitement that's been coming in from the chat. Folks are wondering, will they actually be able to sell and get access to models and features on the marketplace as well?
Yes, absolutely, and that's very important. Is all the way from data directly sharing data on the marketplace all the way to applications, and this application can expose modules, interface APIs, so where you can directly use model, and that this application can underneath, as you saw in the demo, use Snowpark Container Services to deploy these models and make the inference really interactive.
Snowflake Horizon, how we bring all of these governance technologies under a single umbrella. The goal is to have the most comprehensive governance solution in the industry, and we want to enable your organization to know your data, to be able to manage your data across regions and across clouds through a single experience. Snowflake Notebooks. As many of you would expect, there's a notebook experience with multiple cells. They can be SQL, Python, or Markdown cells. It leverages the full power of the Streamlit visualizations and interactivity. Universal Search. It's a single consolidated experience that helps you search and find objects in the data cloud. Hopefully all of you are inspired and excited by the announcements that we have today, because at Snowflake, we innovate just because we know we make you more productive and you get more value out of the data.
All right. Good afternoon, everyone, or good morning, depending on where you're joining us from. My name is Farhan Chaudhary, and I am the evangelist for Snowflake in India. And I welcome you all to this last session of Discover. And I think it'll be sort of a disservice if we don't talk about LLMs once again. Just to wrap this all up, just to conclude this. If you're not bringing up LLMs, then what are we doing? So we are here to talk about that. I'll introduce you to the speaker in a moment. But for those of you who are joining us for the first time, welcome. I'll be very quick with this. I just want to remind everyone that we are talking about some future roadmap items. And from now until the product and the feature gets released, there might be a few changes, albeit for the better. So just bear with us, and remember that whatever we are showing you today is a part of something that is a work in progress. So if you have any questions, just reach out to us. But remember, this is going to be slightly different when this feature is going to be released. We have talked about a lot of features. For this one, we're talking LLMs in particular. I just want to remind everyone that we have covered a whole world of topics. We have gone from basics of Snowflake to data engineering, Snowpark. We have covered Streamlit. We have covered Iceberg tables, Snowpark container services. We have done all of that. We have also covered native application and application architecture supported inside of Snowflake and the marketplace. Now, what we are going to be doing in this session is we'll have another take on the whole LLM story. We have Chuang, who is gracefully agreed to conduct this session. Unfortunately, Fanny, who was going to be the speaker for this session, couldn't join it because of a personal emergency, but Chuang graciously agreed to do this session. It's 7:30 his time, so he's pretty late in his evening, but he is very passionate about Snowflake, and you'll be in great hands in this session. I just want to remind everyone that this is a live event. If you have friends or colleagues who would benefit from this session, invite them. If you have questions, ask those questions using the Zoom Q&A feature that is going to be on either the top side of your screen or at the bottom. And if you haven't already watched the Snowday announcements, please do. There are a lot of feature releases that we came out with, Snowflake Horizon, Snowflake Cortex being the more prominent ones, but there are so many more. So if you're in the world of data and you haven't seen these announcements, please take your time, take this QR code, and definitely watch the Snowday announcements. Now, that being said, let me introduce you to our next speaker, which is Chuang. Chuang is going to walk us through LLMs. And I know we have done a part of this topic on when we were covering Snowpark container services. So there's going to be a little bit of overlap, but we're going to talk about fine-tuning of LLMs, what embeddings are, and so much more. So Chuang, thank you so much for conducting this session. And I'm very sure that the audience is in great hands.
Thank you, Farhan, and happy Diwali to you and all the folks on the call today as well, if you're from India. So should I get started? I'll start sharing screen and we can jump straight into it. Okay. All right. Can you guys, I think, yeah, my screen should be up. Hello, everyone. Awesome. Hello, everyone. My name is Chuang Zhu. I'm one of the senior sales engineers in Snowflake. And as Farhan said, I'll be going through some of the new updates around LLM and AI. So as part of this session today, we'll go through sort of high-level business and technical concepts around LLMs, and then we'll talk about what is LLMs and how they work and why they're relevant in today's world. And then we'll go through a deep dive looking at Snowflake as a platform, how it can harness the power of generative AI for a lot of organizations. And then we'll conclude with a demo as well. So we'll get straight into it. So the first part is really trying to give you guys understanding of the business concepts. All right. So we essentially are in the new age of generative AI, and it's really going to change the way in which we enable our internal teams and also deliver the way we deliver new innovative products. AI is not new. There are many aspects of it that which won't go away. We still need classical AI and ML to do things like business forecasting. But the introduction of deep learning enabled us to do predictive and respond to unstructured data. One of the examples could be analyzing video footages to predict foot traffic and so forth. Okay, but now we can do more with our data, and it's more relatable to everyone within the organization. The only thing is the running these models can be requires a lot of data and also processing power as well than ever before. Okay. And so as this boom in generative AI is happening, what are things that are really going to change the way we move forward? When it all started with consumer-facing products like ChatGPT, as the years passed, we saw a boom in open source models as well, with performance comparable to that of commercial external hosted models. So these models include Llama by Meta, Google BERT, to name a few. Due to the technology, the way we are seeing the opportunities for LLM, and especially for organization, is to acquire industry-specific models, all right? The idea really is to have tailored occurring models that is tailored to the needs and focusing on what the business will need to run on a day-to-day from a specific task or job, but run it in a most cost-effective way, okay? So with that being said, we've covered the business context in terms of LLMs. Now we can look at the fundamentals and try to get a good grasp and understanding of what is LLM and how it was derived from, okay? So to start the journey, the way humans learn languages is very different from how machines learn. For us, language is a mode of expression. We have experiences and observation, and we put into words for conversation. But for machines, it's purely inputs and outputs. A machine is purely statistical and is bounded by algorithms. So the pre-training step is really namely using self-supervised and unsupervised learning on a large amount of data. So you think about corpus of documents and the primary task of predicting words in sentences by learning meaning, okay? So how do we get meaning? The meaning language model is in the form of embeddings. Okay, so embedding is really a numerical representation of words, phrases, sentences that captures meanings and context. So as part of the training step, we encode the words and sentences in a way that it can be processed by machine learning algorithms. So therefore, the closer the two words, the closer the embeddings are. So in particular, synonyms are very close to each other. So in summary, embeddings help in the continuation of sentences as the model tries to predict the next occurrence of a sentence and the follow-up word. So if you think about ChatGPT, if you ever used it before, when you use it for Q&A, you will see the answers returned to you is always going to be word by word. So it's really using the embedding as part of the answering. So with the embedding, you can use it, apply it to novel scenarios, and you can apply it directly. Because it has meaning. So therefore, for use cases such as sentiment and search, direct use of that embedding could be leveraged. So one perfect example could be if you're in an organization and you're trying to analyze multiple different contracts, and then you're looking for a specific clause, and then you require that clause to be amended due to legislation change. So therefore, you can encode that fragment of text, essentially the text that's under consideration, then search all other documents with similar clause across the documents. And therefore you can change in a parallel or scalable approach. So this is the power of semantic search, and you'll be able to use the embeddings directly, okay? Now for the generative part, how do LLMs use that knowledge that you can acquire and adopt to other scenarios, okay? So to adapt a model, for example, into more of a question and answering, or following instructions, the process involves the model to be fine-tuned. By providing the model with many different examples, over time, this process alters the model. So that model itself is no longer a natural language model itself, but it's specialized model now for question and answering or following instructions, depending on how you decide to fine-tune it. And the other example is obviously in-context learning is mainly suitable for prompt strategies. So things like prompt engineering for solving various tasks, such as sentiment analysis. So the key idea with in-context learning is to learn from analogy. We get text, we get examples, we answer the labels and the sentiment, whether it's positive or negative. And over time, it could be used for that use case directly, okay? So that gives you guys a high-level understanding of what LLMs are, and now from a business and technology context, we provided that information. So the next part is really now trying to deep dive into Snowflake and then leverage Snowflake for generative AI with speed and also use it to lower the cost of ownership without losing control of your data as well. So some of the things that we're trying to accomplish within the platform itself, there's 3 key areas. The first component is really trying to protect your most valuable assets. As a fundamental component of any Gen AI or data strategy, making sure your data is secure and it is essentially the focus point for all model and fine-tuning. Having your data within Snowflake ensures that your data will not leave the security premises, and it's always going to be secure and supported throughout end to end. And the second part is really around expanding adoption beyond the AI experts, because of a lot of values can be untapped without having to do custom experience. So as part of a lot of the features that we're introducing this Snowday is to allowing the experience without custom coding. A lot of the native UI capability will be surfaced, which I'll show you the next couple of slides. And then lastly is also keeping developers focused on development. So when you think about developers, their valuable time is really trying to focus on business value and trying to deliver new outcomes for the business rather than maintaining infrastructure or essentially tuning various clusters in the past. So the idea really using their managed service platform enables them to focus on what's critical for the business. Okay. So here we are, the diagram which shows you the Gen AI LLM platform overview. We'll go through each component in the next couple of slides, and we'll cover off the core feature that we're announcing, which is Snowflake Cortex. Okay. So the first part is the experience. As mentioned previously, we essentially have Document AI, Universal Search, and Snowflake Copilot. These are pre-built LLM models under the hood, leveraging Snowflake Cortex, and we'll be able to leverage that within the Snowsight UI. Okay, so what is Cortex? Cortex is a feature, a product that underpins all the new service that we're offering. This new intelligent managed service enable organizations to quickly analyze data and build AI applications, all within Snowflake. We're going to talk about 2 ways users can quickly access and use Gen AI. We'll go through the experiences, which is Document AI, Universal Search, and more in detail. And we can also go through some of the serverless specialized functions and how you can leverage that for new workloads as well. All right. So the next part is really trying to understand why Snowflake Cortex. And some of the easy points is really to identify it's easy to use. There's no need to manage infrastructure or build your own LLM apps, in some case to use for AI in daily use cases. It's flexible. Users can access industry-leading AI models, LLM, and vector search functionality very easily with SQL or Python functions directly. It's cost-effective. Compute is optimized for inferencing. Search to run your data already exists in secure governed state already. And then the 3 core experience capabilities is obviously Document AI, Snowflake Copilot, and Universal Search. So the first part is Document AI. What is Document AI? It's a new workflow that allows you to extract content from unstructured data. So if you think about organizations that has a lot of contracts, a lot of text or document, call centers that has a lot of various transcript, in order to analyze and get value and critical data sets from this information, Document AI can retain and extract analytical value from this information without any AI expertise. And then from that, you can ask questions using natural languages to effectively answer and get answers. And then you have the option to fine-tune certain results. So you can tailor a lot of the workflows according to you and your organization's needs. And this feature is going to be built in directly in Snowsight. There's no code UI as well. The second component is really the Universal Search. It's essentially the semantic search capability within Snowflake. You'll be able to search and discover tables, views, database schemas, all the various objects available to you as a first-party product. But you can also search marketplace listings as well. So it can be very helpful for a lot of the native apps and data sharing capabilities. You can always find data apps from your Snowflake account on what you're looking for. Okay, and this feature will be directly available through the Snowsight UI as well as an additional experience. And lastly is really Snowflake Copilot. It's an LLM powered assistant that brings the power of generative AI to your Snowflake account. So you'll be able to generate SQL code based off natural languages or through conversations. It will definitely improve productivity within the organization. It will be able to develop much faster. And again, the feature will be available directly through the Snowsight UI. Okay. And then as part of the experiences, if you were to go down the path of leveraging, obviously, Snowflake Cortex, and you want to build your own applications directly, you can leverage Streamlit. And then we'll talk about how you can leverage Streamlit and some of the specialized functions within Snowflake Cortex to enable that feature as well. So first, we can talk about the specialized functions that will be offered within Core Cortex. You can invoke these functions via SQL or Python directly within your code. Because obviously with Streamlit, you can use that within a Streamlit app hosted natively within Snowflake using Python code. But in summary, the functions include translate, summarize, extract, answer, sentiment detection as well. So just a sort of high level context around the functions. Translate is really translating a given text from a supported language to another. Summarize is to return a summary of a given text. It would be very useful for transcripts or large amount of text within a contract or document, for example. Extract answers is really the Q&A. Given a question and text, it will return answers to that question if it can be found in the text. And then sentiment is really giving you a score representation of overall sentiment of a given information that you provide. So you can provide a sentence, and then sentiment detect can give you a score based on that sentence as well. And then on the right-hand side, or one last thing with the LLM-based special functions, majority of this function currently has just been announced. So it's be mindful that it's currently in private preview at the moment. And then the right-hand side, we have the ML-based functions. So ML-based functions has been in public preview and it'll be GA soon, especially with forecast and anomaly detection. The difference is with ML-based function is pre-trained models under the hood. For forecasting, for example, you'll be able to tie it up with your time series data, and Snowflake could effectively provide a forecast for you automatically. And you can leverage anomaly detection, top insights, and classification as well. So these are all pre-built, pre-trained functions that you can invoke directly within your Snowflake account across structured data. Okay. And then from that, it will enable you to build your own applications. So these predefined functions through LM or ML power functions, you can use these functions across your data and then surface that information in Streamlit. So turn your data to really an AI-driven or AI-powered application directly and empower your stakeholders so that they can gain insights and trust within the result and information that you have. And then we look at now further on to look at a customization. So this is really going to be focused on container services. And we'll talk about how you can leverage partner LLMs, open source LLMs, and fine tune that LLM, and then bring that to life using custom UI as well. So what is container services? I think the previous session we already went through it, but the idea really is to enable developers to deploy container images in Snowflake. Okay, so it provides a flexibility for any developers to bring any code, runtime, framework, app stack to Snowflake with their data, as well as the ability to choose CPUs or GPUs based instance as well. So why will customers want to run their containers within Snowflake? The first point is really ease of use. So there are a lot of complexities running containers on the cloud. So namely Kubernetes, AKS, there's a huge learning curve for a lot of users. Most of the audience that we talk to from a Snowflake side of things are mainly data engineers or data scientists. So they're not experienced in terms of running containers and etc. And then the other part is really around the maintenance aspects. To have a container services running in production, a lot of the app specialists spend around 20% of the time scaling, maintaining, and operating clusters rather than really focusing on the value and delivering to the business as well. And the second crucial value proposition is really around the ecosystem. You can essentially tie up the containers with your Streamlit application. So therefore, you never have to move your data out of Snowflake. So therefore, it's secure, it's protected, and you can focus on your business going forward. And in the future, if you ever decide you wanted to develop an AI application and you want to monetize it within Snowflake, you can easily put that on the marketplace, and that will be served via a Snowflake native app. So it allows other consumers to leverage and use the application you've built, but then you can also monetize that application that you've hosted as well. Okay. And then from the list of the various already ready service partners for container services, we can see there's DataIQ, Hex, and obviously for LLM in industry models, that includes AR21 Labs and NVIDIA. Okay, so these are all partners that developing the application in container services and are running that within the Snowflake marketplace as well. Okay, and then one of the things that I missed out was there's really 3 ways you can actually host an LLM within Snowflake. You can leverage partner-led. So there's industry LLMs inside of the native apps framework. It's going to be running securely within your Snowflake environment, but it's hosted on the partner's environment. So it's really a multi-tenant approach. And then you can essentially use your data against the partner LLMs by a consumption model. It's purely token based, so you pay for what you use as well. The other option is bring your own LLM. So if you want to use Hugging Face or download Llama for example from the Meta, it's very compatible to OpenAI. Customer can then download that image and host it in a container within your Snowflake environment, and then with that container you can fine tune and then develop your own industry standards around how you interact with your data as well. Okay. All right. So we've gone through all the slides at the moment. So that gives you guys a high level context of what's coming and what we support. I guess right now it'll be a great opportunity to jump into a demo to sort of showcase how you can use container services and host your own LLM. So I'll jump into a quick demo here. So the demo will just showcase you how we're going to host our own open source LLM. So right in this web link, I've got Meta, which is Llama. You can see here, it's Llama from Hugging Face. We've downloaded the image and we're going to push that into the container services on our Snowflake account. And we're going to run it for a large amount of data and trying to summarize transcript as well. Okay. So I'll get the link here for Llama. And then the next thing, what you need to do is have VS Studio or a client tool. But the idea really is that you have a Docker image. So for everything that you use for container services, there'll be a Docker image and a YAML file. So a YAML file obviously is a configuration of the services, and the image will have obviously the LLM downloaded directly. So as you can see here, I've got an LLM folder, and I've also got a Streamlit folder here as well, comprising of a Docker image for the Streamlit app, and also a Streamlit YAML file, which has the service configuration. Okay. And then what we can do natively in here, we can push a image directly to our Snowflake account. So there's 2 components you need to push. One is obviously the Docker image. You need to push that directly to your Snowflake account within a stage, and also pushing the YAML file as well. So these 2 components needs to be pushed directly into your Snowflake account to manage and create a container service. So I've already pushed the image for Llama already. Previously, you can see the layer already exists. So we can jump into our Snowflake account and see how you can start creating compute pools and then run these containers across your data. All right, so here we have a Snowflake demo instance. The first thing I want to do is I want to show you what we're going to use the Llama container service for. So we have a table which includes customer support transcripts, okay? And in here we have a transcript, and the transcript includes information about people's experiences, about a flight, and some of the information here. It's a large amount of text, right? So what we want to do is we want to use natural language and then LLM to essentially process that to summarize that information. And we will use the Llama container that we pushed to run a function against that data. So the first thing is that we need to create what we call a compute pool. Okay, so the syntax is just create compute pool and then give the compute pool a name, and then you can select a type of instance. So this could be GPU 3, and there's also GPU 7. We've previously already created the compute pool. So we use show compute pool here, and then we can see all the lists of the compute pool names and which ones are active. So right now, the GPU 3 is currently in active mode, so we can actually use it for our services, okay? All right, the next part is we also have a stage. As mentioned previously, we pushed the YAML file and also the image. So you can see here, the LM YAML, the Streamlit YAML has been pushed directly into the Snowflake stage so that the service can be created. So once that is done, we need to create a service. So the two services that we're going to set up is create service. We're going to create Llama 2, and then we point it to the compute pool that it will use, right? So as we can see previously, the GPU 3 is currently active. And also we need to give it the service configuration, which is the YAML file. So these two services has already been created. So I'm creating the two services for the two containers. One is Llama 2 and the other one is Streamlit. So if we go down and say show service, you can see the two containers for the service is running, the compute pool is there. And then as part of that, you also get public endpoints. All right, so this is essentially the public URL you can access for the containers itself. So we can look at the Streamlit container, and we'll just punch it in here. Okay, so the Streamlit app is a simple LM. It does a lot of Q&A, but it can also extract information from a transcript. So here we're just doing some prompt engineering to say summarize the following transcript in business context, right? So we'll run the extract information. So as you can see, it will summarize that information in business context and provide a meaningful information that we can use for the business itself. Talks about our customer has contacted the airline customer service and reported a recent issue, including delays with flights and seat mix-up. Okay, and then we could also ask the simple LM, what's the best burger place in Mumbai, for example. Okay, so and then this is essentially interacting with the LM through a Q&A fashion. I've never been to any of these spots, but if I was ever in Mumbai, I'll definitely try one of these burger places to see how things are going. You guys got bodega, which is awesome. Okay, it's good to know. So here we are. Okay, so you can see the Streamlit app is hosted in containers and is running off the compute pool that we provision for the GPU nodes. Okay. And then we can jump back in, and there's system functions which you can leverage as well. So you can see here, system get service status. So this will allow you to point it to the service and gives you an information on whether the service is running, whether it's ready, whether it's pending, and etc. So you can see both the services are currently in ready state. And you can also use queries to use the get service log function to actually get log data. So if, for example, the containers takes a long time to come up, to become ready, you can also analyze the log data based on the container as well. So that's all pre-built metadata for you to use as part of the container services. Okay, here we are. Okay, so show services. So that's the endpoints that we showed previously. Okay, so the next thing I want to do is I want to create my own custom function. I want to be able to input a text, and I want to be able to say extract the information and return it in JSON format. Give me the root cause, the resolution, and the sentiment of the conversation of the transcript. Okay, so in order to do that, the function is created called LLM. The input is just text, and the return will be text as well. You can see here I'm using the service, which is the Llama container itself, and then the endpoint is chat. All right, so this function has already been created. So I'm going to run the transcript column against the LLM function, and then we'll run this and return these 4 values: core summary, root cause, resolution, and end customer sentiment against our data. Here we are. All right, so the result is returned. So the first part is summarize the complete end-to-end text and the transcript. It says customer contact the airline to address issues with recent flight. The root cause is unforeseen maintenance issues and last-minute aircraft change led to delays and seat mix-up. And then the resolution is representative of a goodwill gesture voucher for future flights and refunds and extra seats fee to set up customer for flight positive for flight notification. And the sentiment is obviously positive. So just showing you guys the power of the container services tied together with either custom function, or you can leverage the Cortex specialized functions in the future and tie that together. You can surface it within a Streamlit app that could be shared internally and externally as well. So that's all I have for today. I just wanted to check to see if there are any questions in the webinar. Okay, it's all good for now. Hey, Farhan, are you there? Ah, here we go.
All right. Hey, John.
Hello. It seemed like all the Q&A answers has been answered.
Yes, we had Rita is going at it. Questions, yeah. I also suspect there were parts of the session that was also covered yesterday and today. So it's great to reinforce the same message and whatever we are doing with this. There is one question though. Well, there are a couple of questions, so I'll just bring them around. So there's a question from Amarnath who asks, is the text dynamically generated or is it a static one?
So the text from the function is dynamically generated. Yeah, so this function here for the LM is dynamically generated, and it's powered by the natural language model Llama behind the scenes.
Got it. There's one question from Vikash who asks, what does the cost breakup look like? So whenever you're using this, what does, what's the impact on the dollars, on the billing, and if you have any information on that?
Yeah, so we will be announcing the pricing for GPUs and obviously using the container services. So the core focus, the cost is around the compute pool, right? So we have your traditional Snowflake virtual warehouse costs, but the cost with compute pools will be separate and the pricing will be released shortly, but it will be consumption based. So it's purely based on when you use the CPUs or the GPUs going forward for your use case.
Wonderful. Once again, I'll encourage everyone to ask questions using the Zoom Q&A feature. If you have questions, please write them down. We have experts at hand live for you who will be more than happy to answer these questions. We did have some questions previously that were answered, but I think this one is a bit special. And I'll just bring this up to see, what our take on this is like. So with things like sentiment detection, are there possibilities to train it for regional dialects?
Regional dialects, yeah, I'm pretty sure you can, but obviously it depends on the language, and obviously it's really a specialized model, right, based on the region. So you therefore might have to look for a specific model that you want to fine tune or run through in your own region. And then I see another question around tokens in general, what we have seen from other LM providers. So to answer your question is, in the future, you'll be able to leverage partner hosted LLMs, so industry LLMs through AI21, through NVIDIA, for example. Their approach really is a multi-tenant architecture. The idea is that they'll host the LLM, and then you have a pointer or tap and call the various functions that they provide. So you can consume and use the LLM against your data. And the way that it's charged is all consumption-based. So we're going to be using what we call tokens or, credits or tokens. That's essentially how you pay for that interaction.
Great. There's a question from Praveen who asks, do we need any LLM subscription like ChatGPT to set up the LLM chat?
The LLM chat, which I showcased, that's managed and hosted within Snowflake. If you wanted to use ChatGPT, which is offered by OpenAI, Snowflake allows what we call external access. So it's essentially having an integration point to your ChatGPT endpoint, and therefore you can pass information. But the main difference is of hosting your own LLM and using OpenAI or ChatGPT is when you use an external access, your data is moving out of Snowflake to then is returned back into Snowflake. So that's the main differential. Okay.
Awesome. Question from Harshit who asks, can we do distributed model training fine-tuning using Snowpark container services? And I think this will sort of also answer the question on regional dialects and a bit of fine-tuning. So I'll let you take that.
Yeah, it's definitely you can. So you'll be able to run any application, any tech stack. I think there's vector databases being hosted in containers as well. So the art of possible is made available through container services. And then you can leverage any type of compute as well. So CPU and GPU for that particular use case.
Super. We have a question from Palaniappan who asks, do we need a separate OpenAI key to use this LLM? I'm suspecting the OpenAI one, yeah.
So again, from the previous question, when you use the OpenAI, it's externally, it's a ChatGPT. So you're using the endpoint externally from Snowflake. You can use Snowflake to connect to that endpoint, but you need to pass data back and forth between these 2 points.
Got it. We have a question from Hemant who asks, is universal search the same as the data catalog feature, or is it something more? And is it possible to see a glimpse of it?
Okay, so the universal search is different. It's essentially a new offering. Will be built in the Snowflake UI that will allow you to search for various objects, whether that be first party or even third party in the marketplace going forth. Allows organization to find information rather quicker.
Excellent. A question from Santosh who asks a question on Snowflake architecture. So do we support automatic scaling of resources based on data volume, and how do the workloads work and how if they fluctuate or not?
Yeah, so if you're talking about container services, so the compute pool at the moment, once it's currently in private preview, so it doesn't allow auto scaling or auto suspend at the moment, but that capability will be built in when we go to GA. So once we go to GA, all of the infrastructure will be managed for you, so you don't have to worry about the complexity of that.
Right. Another question on Document AI. Is it possible to read text from an image, and if different languages are supported?
I'm pretty sure it can, because obviously it classifies unstructured data, so leveraging OCR technology as well as part of that. So I think most likely can, but obviously we have the acquisition of Applica that has a lot of the capabilities on extracting unstructured images, for example, and then you can then use that analytical value for text as well.
Got it. There's a question from Praveen who asks, what are the timelines for GA for hosted LLMs and Streamlit? So both are separate.
Okay, so I think Streamlit in AWS is getting close to public preview, I believe. Hosted LLM, which is essentially container services, which you onboard with the open source LLM. So right now they are in private preview, but the idea is that we're trying to move towards a GA timeline of around April to May next year. But obviously these timelines are not guaranteed, and things might change, but that's currently what we anticipate.
Super. There's a question from Santosh who asks around the data security and compliance within the LLM environment. And, right off the bat, I'll just, tell the audience that the image that you saw of the entire vision for LLMs, building AI in seconds, minutes, and days is all happening with, inside the secured perimeter of Snowflake. But I'll let Chuang take that.
I think you answered it perfectly, Ryan. So everything that you run in Snowflake is within Snowflake secure boundaries. So therefore, the containers, your data, obviously, it's all managed and protected within the Snowflake environment. And then if you want to talk about governance, governance is features that we provide as part of the service as well. So governance is more relatable to data. So if you want to protect your data through column level or row level security, or you want to do various capabilities like classification and tasking. So it's really purely based on data. But if it's container specific, it is definitely within the secure boundaries.
Excellent. A question from Monica who asked, we have a boot camp for developers. Do we have anything for data engineers as well? I'm not sure if, this boot camp is the same one that we have been talking about and the one that we are going to be conducting in the future. But, a long answer to that question is that yes, we have lots of boot camps and anyone can attend it. If you're an analyst, if you're a student, or if you're a data engineer, data scientist, I'll share a link with you very shortly. We are conducting Snowflake Ascent, which is our training program. Again, absolutely free of cost. Think of it as a boot camp. We do a lot of these boot camps, at different times of the months and throughout the year in different locations. So, for example, if you are joining us from India, we conduct a lot of different programs that are India specific. We meet up quite regularly. We have a user group that meets up quite regularly, so you can join us over there. We conduct some hands-on workshops and boot camps there. And if you're joining us from any other country, then we have a chapter essentially in your country as well. More likely than not, we are going to have a chapter there. And then we do a lot of virtual programs that you can join us from anywhere at all. So yes, that's a long answer to your question. So we have lots of boot camps. There is Ascent that is coming up. In fact, let me bring up my screen real quick and tell you what we are going to be doing next month and what we have in mind after that. So there's Build that is coming up on 5th and 6th of December. Again, this is virtual, free of cost. We're going to talk a lot about hands-on stuff. We are going to cover a lot of workshop, hands-on labs and such. So if you want to join this event and essentially be a part of that, a bootcamp light version, then this is going to be it. If you want to be a part of a bootcamp version, then this program is meant for you. We are doing Snowflake Ascent. The QR code is right here. If you're in the India region or around the India region in Southeast Asia, then you can join us during the Asia time. Or if you are in ANZ, Japan, you can join that time zone. It's a full day of learning and upskilling. And we are going to provide this once again, absolutely free of cost. And by the end of this workshop, once you have successfully completed all of the required elements, you'll also get some bragging rights and a badge that you can flaunt on your network and put it on your resume. So this is going to be a great opportunity for anyone who is looking to upskill. Remember, we have chapters established in Delhi, Bangalore, and Pune. If you are in any of these cities, if you're in India, and if you're in any of these cities, come meet us. We are meeting next month. We have an active community and a user base in all of these cities. We come brainstorm ideas and work on solutions. So come meet us. And if you're not in India, if you're from any other part of the region in APJ, then community.snowflake.com is your friend. Search for your city and meet up with your peers and network and grow your, have some more chances at learning what others are doing in the community. Now, that being said, I'll take a pause. I don't think there are any more questions here. Once again, thank you, Chuang. I think you're in the backstage, but thank you so much. We have shared a link to Snowflake Ascent in the chat, so you should have the link with you. And with that, I'd like to bring Discover 2023 to a close. We have done so much throughout the year. We did a workload edition in the beginning of the year. We went through data warehousing, data lakes, data engineering, data science, machine learning applications. So we did the whole workload piece of it. We had some major announcements during Snowday. We have shared the link with you once again. Go watch those announcements. And we covered a lot of those announcements as a part of our slides during Discover. And we are not done yet. We are going to be meeting. We are going to be doing a lot of developer focused events. End of year, this is where we feel you guys have a lot of time. And then we also are in a state where we can walk you through all of these amazing hands-on labs that our engineers have created for you. With that, thank you so much, everyone. You've been a wonderful audience. And I'll see you once again at either of the meetups or next year at any one of our events. I know it is Diwali next week for all of us joining from India, or if you're a fan of Diwali, the Festival of Lights. Wish you all a very healthy and a safe Diwali to you and your family. Thank you so much, everyone.